A very warm greetings to all of you. Respected Chief Guest of the Day, Engineer Udayan Pathak, DGM Engineering Research Center, Tata Motors, and RC member CSIR-AMPRI Bhopal. Special guest Dr. S. Manjini, Associate Vice President, JSW Steel Limited, as well as RC member CSIR-AMPRI Bhopal. The Director of CSIR-AMPRI Bhopal, Dr. Professor Avnish Kumar Srivastava, distinguished speakers of the program, Dr. D.P. Mandal, Engineer H.N. Bhargav, Dr. Ketan Apte, Mrs. Geeta Apte, Shri P.A. Sardar, Shri S. Srivastava, respected dignitaries, researchers, scientists, teachers, principals. Ladies and gentlemen, a very warm welcome to all of you in this very special, auspicious occasion to celebrate the Festival of Science, that is National Science Day. As we all of us know that the National Science Day is celebrated in India on 28th February each year to mark the discovery of the Raman effect by Nobel laureate and Indian physicist Sir C.V. Raman on 28th February 1928. This year, the theme of the Science Day is the future of STI, impact on education, skill, and work. Science is an inseparable part of our lives, be it our daily works we do, the technologies we use in our academic, in our daily life, developing skill, even in outside the space mission, everywhere. We cannot think about anything without the science. Nothing is left untouched without the science. This National Science Day is celebrated to encourage every one of us to give our best in bringing new innovations in science and technology, to create awareness about the innovations, discoveries, and invention among the people which are related directly or indirectly to the science. With this hope of igniting our minds for fulfilling the purpose of this special day and directly asking us into a new era of scientific innovation, let us celebrate this day. Ladies and gentlemen, before I start with and I invite Professor Avnish Kumar Srivastava, Director, CSIR-AMPRI Bhopal, for his welcome note, I would like to share his CV with you. Professor Dr. Avnish Kumar Srivastava has a very long list of achievements, and it is rarely very difficult to put it into the words. Professor Srivastava earned his Master's in Physics from IIT Roorkee and Master's in Technology in Material Science from IIT Kanpur. He holds PhD degree in Meteorology from IISc Bangalore. He is known for his knowledge and expertise in the field of materials, processing, characterization, semiconductor science, nanostructure materials, composites, and so on. He has more than 300 publications in high-impact journals with more than 5,000 citations. His work was also highlighted in Science, which is one of the most renowned journals. It's our privilege to mention that Professor Srivastava, Director CSIR-AMPRI Bhopal, has been recently identified Stanford University among top 2% most cited scientists all across the world. Along with the deep knowledge on the fundamental science, he also has a command on the technology development, and he has more than 15 national and international patents and almost the same number of know-how transfer technologies in his credit. He is currently serving as Chief Editor for the Applied Innovation Research Journal. He has been very instrumental in establishing various research facilities at CSIR, NPL, as well as CSIR, NP. Among these most important facilities that have been established by Director CSIR-AMPRI are transmission electron microscopy and electron energy loss spectroscopy that are very few all across the country. He has been the fellow of member of very prestigious organizations like IIM, MRSI, Mineral Metals, and Material Society USA, EMSI, and so on. It is our great pleasure to mention here that now Professor Srivastava is the President of Electron Microscope Society of India. He has a number of awards on his name. Few of them are NMD Meteorologist of the Year Award by Ministry of Steel, Government of India, MRSI Medal, INSA COSF Fellowship, Boycost Fellowship, and so on. Ladies and gentlemen, the list is very long. Professor Srivastava is also serving in various committees of Ministry of Science and Technology like TIFEC, DST, Standing Scientific Advisory Group by Ministry of Mines, and so on. He has also worked as National Coordinator in Bureau of Indian Standard and immensely contributed in ISO 2. He has worldwide contribution where he is closely associated with various institutes. Some of them are Argonne and Brooklyn National Laboratories of USA, Technical University Darmstadt, Germany, Department of Energy, Italy, Okayama University of Science, Japan, AMI Cotton Labs, France, Postec, South Korea, and so on. It's really a long list of achievement, Professor Avnish Kumar Srivastava. And now I would like to call him for his welcome address, Professor Avnish Kumar Srivastava. Sir, please.
Good morning. Namaskar आप सभी को. Wish you all a very happy National Science Day. As we all know that we celebrate National Science Day to commemorate the discovery of Raman effect by Nobel laureate physicist Sir C.V. Raman on this day in 1928. National Science Day is celebrated to spread a message about the importance of science used in the daily life of the people. It is celebrated to discuss all the issues and implement new technologies for the development in the field of science. The slogan of the day is also to encourage the people as well as popularize science and technology. Today's program is being organized jointly under the umbrella of CSIR-AMPRI and CSIR Jigyasa. CSIR Advanced Materials and Processes Research Institute, in short CSIR-AMPRI in Bhopal, was established as Regional Research Laboratory RRL in Bhopal in the year 1981 as one of the constituent lab of CSIR, that is Council of Scientific and Industrial Research. At later stage, the lab was renamed as Advanced Materials and Processes Research Institute AMPRI in the year 2007. CSIR-AMPRI is the only CSIR lab in the entire two states of Madhya Pradesh and Chhattisgarh. In addition, this is the only lab of CSIR which is completely dedicated on carrying out R&D on advanced materials and advanced processes. We are working on lightweight materials, including various kinds of foam for automobile and strategic sector, including energy devices, waste to value-added materials for efficient utilization of industrial and agro waste for various construction purposes, radiation shielding and cement-free concrete materials for health sector and other radiation shielding aspects. Moreover, cement-free concrete materials for civil construction, smart and functional materials for automobile and purposes for sensors and actuators, nanostructured materials for various possible applications, applied biomaterials for health sector, including biosensors and other devices, polymer composites and bamboo-based composites for construction purposes and for replacement of wood, and also in the field of rural technology and water resource management. All above activities are being implemented under 6 divisions and 1 center. Namely, first is Alloys, Composites and Cellular Materials Division. Second, Green Engineered Materials and Additive Manufacturing. Third, Intelligent Materials and Advanced Processes. Fourth, Industrial Waste Utilization, Nano and Biomaterials. Fifth, Hybrid Building Materials and Manufacturing. Sixth, Water Resource Management and Rural Technology. And seventh, Center for Advanced Radiation Shielding and Geopolymeric Materials. All these divisions are formally independent within the system and have got equal opportunities in terms of infrastructural support, etc. The laboratory is involved in publishing high impact factor articles in international journals, filing national and international patents, and also good number of technology know-how transfers to starting from startups to high-end industries like Messrs. MW Social Enterprises, Indore, Messrs. Prince Johnson, Mumbai, Messrs. Parmali Wallace, Bhopal, and so on. We are also engaged in conducting PhD program on above said materials and devices in the field of engineering sciences, chemical sciences, and physical sciences through ACSIR, that is Academy of Scientific and Innovative Research under CSIR. In the last financial year, we have completed 43 projects. Among those, about 50% funded from outside CSIR. That is from other government agencies and industries. And we are 44 scientists, along with a great support from technical and non-technical persons, including admin, purchase, finance, ESD, research students, project fellows, PhD students, and so on. These projects leads us output in the form of publications and patents, products being matured in the form of technology know-how transfer. On an average, we are publishing around 70 to 80 papers in internationally reputed journals, 12 patents, and several technologies know-how on annual basis. Even in the pandemic situation in last about 10 months, with our 44 scientists and support system, we have published more than 100 research articles in SCI journals with high impact factor of journal like Nanoenergy having impact factor 16.29. We have filed around 6 patents and transferred 5 technology know-how, including a technology of makeshift hospitals clinic with joint efforts of CSIR's Central Building Research Institute, Roorkee, and CSIR-AMPRI. I would like to further add here that CSIR-AMPRI transferred a technology know-how for surface plasmon resonance SPR Raman substrate to Messrs. Technos Instruments Private Limited, Jaipur on 3rd January 2020 during the inaugural day of the 107th Indian Science Congress held at Bengaluru. We all know that Raman spectroscopy is very versatile technique. The effect was originally detected by Sir C.V. Raman in 1928. Even though Raman effect was invented in India, there has been very less technology development in spectrometers or lasers. Hence, most of the Raman spectrometers are imported in India. Raman spectroscopy can help to solve many of modern day problems faced by Indian society. One step in this direction is this know-how CSIR-AMPRI have developed, which is an unique approach for making Raman substrates, which utilizes the localized surface plasma to enhance the Raman signal several fold in commodity Raman spectrometers. These techniques have wide application in pharmaceutical industries for detecting contamination in medicines or the fake medicines, detecting adulteration and contaminants in food and water, forensic, etc. Messrs. Technos Instruments Private Limited, Jaipur is in process of developing indigenous portable Raman spectrometer in association with CSIR-AMPRI. And we are quite hopeful that within a year or so, this product should be in market. We are fortunate to have today 2 very distinguished guests, Dr. S. Manjini, Associate Vice President, JSW Steel Limited, and Engineer Udayan Pathak, Head and Deputy General Manager, Engineering Research Center, Tata Motors, to celebrate National Science Day 2021 with us. Both the guests are also fortunately the newly constituted present Research Council member of CSIR-AMPRI. On this occasion, we are also going to hear from our distinguished speakers, Dr. D.P. Mandal and Engineer H.N. Bargo of CSIR-AMPRI and Dr. Ketan Apte, Director, Messrs. Apt Medical Systems Private Limited, Pune. Indeed, we are also fortunate to have with us school children of Kendriya Vidyalayas of Madhya Pradesh and Chhattisgarh, Navodaya Vidyalayas of Madhya Pradesh, Chhattisgarh, and Odisha, along with their teachers, principals, assistant commissioner, and deputy commissioners, and their family members too. This team in today's program is led by Shri P.S. Sardar, Deputy Commissioner, NVS Bhopal, and Shri Shobhit Srivastava, Deputy Commissioner, KVS Bhopal. CSIR Jigyasa program is a dream project of our Prime Minister of India. Under Jigyasa program, CSIR has signed the Memorandum of Understanding MOU with Kendriya Vidyalaya Sangathan KVS on 6 July 2017 to launch Jigyasa program, a milestone event in the gracious presence of the then Honorable Minister of Human Resource Development and Honorable Minister for Science and Technology and Earth Sciences and Environment, Forest and Climate Change. Jigyasa envisages a wide-ranging scientist-student connect programs to inculcate recent science and technology development under young minds. On March 13, 2020, an MOU was signed between CSIR and Navodaya Vidyalaya Samiti, NVS, to implement Jigyasa, which connects all students and teachers of NVS with 37 CSIR labs across the country. With this brief note, on behalf of CSIR-AMPRI, CSIR Jigyasa, and also on my personal behalf, I welcome all of you for today's program, that is National Science Day, and I wish for its great success. Thank you. Namaskar.
Thank you, sir. Thank you for the welcome address. Now to move ahead, ladies and gentlemen, and before I call the special guest for the presidential address, I would like to share the details with you. We are really proud to have Dr. S. Manjini with us in this special occasion. Dr. S. Manjini is Associate Vice President, JSW Steel Limited, and as well the RC member of CSIR-AMPRI Bhopal. He is ME and PhD from IIT, Indian Institute of Science, Bangalore. He has having more than 24 years of experience at JSW Steel Limited. He has around 11 national and international patents in his credit. He has also published more than 20 research publications in various reputed journals. He has been actively participating in various seminars, workshops, conferences, where he has presented around more than 60 papers. He has the recipient of various awards like IIM, ISR, Gold Medal, etc. He has also been the member of various reputed international organizations like AIST USA, TMS USA, and the list is so on. Now, not taking much of the time, I would request our special guest for his presidential address, Dr. S. Manjini, sir, please. Thank you, sir.
Thank you for a nice introduction. Good morning, all. First of all, I thank you for giving this opportunity to deliver the address in this August occasion. And even first and foremost, I thank the Director General CSIR and Director AMPRI, Dr. Avnish Jigyasa, for including me in the research committee as a member. Like Dr. Jigyasa said, that the National Science Day has been celebrated as the day when the Raman effect was discovered by Raman. So anyway, I've been working in the industry for so many years, so I'll not be able to go too much into the science of that. So what I'll do, I'll deliver a short address, what I am comfortable with, and we also will set a precedent for what kind of research we are expecting from the CSIR labs in the near future. Okay. From the address of introductory welcome address of Dr. Avnish, we understand that AMPRI has been doing a lot of work on the advanced light material program, particularly for automotive. Not only that, also with the research on waste utilization of the particularly the industrial waste and utilization of those materials for the betterment of the society and the environment. So today I'll be addressing towards a greener environment with setting a reference to Mr. Udayan Pathak's lectures on lightweighting of automobiles. Okay. So the moment we talk about environment, what comes to our mind is that immediately everybody talks about the carbon dioxide emissions from the vehicles, because every winter we hear that because of the vehicular emission pollution, there is a lot of fog and other things in the northern India. So that's what comes to everybody's mind. But as you see, I'll share a small slide, a couple of slides, which is not actually a presentation part, but it's setting the context for my talk. As you are aware that we have the BS6 norms has been introduced in India in 2020, well ahead of the original target of 2021. In fact, we are at par with the, just give me a second. I should be, sharing screen. Yeah, we are originally it was intended in 2021, but we skipped that from BS4. We skipped the BS5 step, and then we have gone to BS6, which is as good as the Euro 2020 now. But actually, if you see, I think I picked up the wrong presentation. You have to pardon me. Okay. This is just comparison of the vehicles, like when we talk about the vehicular emissions. Auto industry is into research for quite some time how to reduce the vehicular emissions. So the first and foremost everybody proposed is the use of electrical vehicles. But on today's context, that most of the electricity, particularly in India, comes from the fossil fuel. If you see that comparison, a conventional vehicle, the total life cycle emission from a conventional vehicle, and the electrical vehicle, where the electrical power supply is from the fossil fuels, coal in this case, is more or less comparable, or even the electrical vehicle is much higher because there is the manufacture of battery coming into the picture in addition to the regular vehicle. Of course, when the entire electricity is generated through the renewable electric power source, then vehicular emissions comes to almost nearly 1/3, where the emission is only the emission which is due to the manufacturing of the vehicle. In this graph, if you see that blue color is the one which shows what is the carbon footprint of the vehicle from through the entire stage of manufacturing of the vehicle. The orange one is the fuel, basically what is the carbon footprint during the manufacturing of the fuel from the extraction till the refining, everything. And the dark brown is the vehicular emission. So naturally for electrical vehicle there is no tail end emission, but then most of the emissions are from the fuel and the manufacturing of the vehicle. So roughly you can say that about 20% of the life cycle assessment of a vehicle, if you take, the 20% of the carbon footprint comes from the manufacturing of the vehicle. So this is where the various research effects which are going into the development of lightweight material comes in. So the one way to reduce the tail end gas emission and the production cost is lightweighting the vehicle. So you know that typically car, medium-sized car is about 1 ton, of which if you take currently all of them are made with the steel. About 800 kg is a steel, 200 kg goes to the rest of the other plastics and other foam material. So by lightweighting the car per se, the steel, by say about 20%, you can reduce the impact of the carbon footprint at the manufacturing cost. Or if you're going for alternate material like aluminum-based alloys, you can reduce the tail end gas emission throughout the entire life of the car. Okay. So when you say that about a medium-sized petrol car, it emits about 35 tons of CO2 in its lifetime of, if you consider about 20 years and about 2 lakh kilometers of service. And so like from the graph, what you're seeing, that 80% is because of the tail end emission, about 20% is from the manufacturing. Okay. This is the other way of comparing it. Like there is the average Euro car, which is a petroleum run. The model what they're talking about, Toyota Prius, is the hybrid one. So instead of currently switching out entirely to electric, it's a hybrid one where the braking energy is used to generate electricity and used to run the vehicle to some distance, or used to use for the electrical accessories. So still we don't reach the level of 100% electrical vehicle norms. These are the various stages where the carbon footprint comes in. Like we say that first 4 are from the manufacturing part, and the 5th one is the current vehicle emission norms, where we are from BS4 by switching out BS4 to BS6, and then further what we are planning to reduce it to about 80 grams per kilometer. So that is where we can targeting from the tail and gas emissions. If you consider the manufacturing part itself, the material powertrain and component manufacture itself considers about, you can say 75% of that 20%. That's about, if you take about 35 tons of CO2 emission, about 15 tons comes from the, maybe about 7 tons comes from the manufacturing of the vehicle, the material cost of the vehicle itself. Okay. So what are the various researches going on? One is the raw material usage itself. The more and more we are going in for recycling material instead of producing the material from the raw ore, which reduces the carbon footprint and of course the extraction cost of the material. Then at the component stage, we are lightweighting the material, trying to replace the material with lighter components. And next comes the processing of the material itself. Like for example, when you talk about the steel, in a blast furnace, we use about 400 to 450 kg of coke for every ton of hot metal produced. I'm not talking about the steel here, only the hot metal produced. That means every ton of hot metal we produce, we generate something very close to 1.5 tons of CO2. If you consider, this is not without considering the electrical power and other ancillaries required there. So if I consider the entire steel production, starting from raw material extraction till the cold roll sheet, we generate something about 3.2 tons of CO2 per ton of steel. So the larger chunk of the carbon footprint in the manufacturing comes from the steel production itself. So how do we reduce this? We talk about alternate methods of ion making now. Instead of using carbon, we can reduce the hydrogen. In fact, most of the European countries have set a target of carbon-free ion production by year 2050. So entirely using hydrogen. Again, it depends on how the hydrogen is generated. If the hydrogen is generated through the most common way of producing hydrogen is by electrolysis of water, which produces hydrogen and oxygen. And if hydrogen is used for reduction of iron ore, unlike reduction of the carbon which regenerates CO2, reduction with the hydrogen actually produces oxygen, something about 0.5 ton of oxygen for every ton of iron you produce. But that depends on what kind of electricity you are using to generate hydrogen. So unless the entire, like I said, that for electric vehicle, entire electricity is produced through the renewable source, the reduction with the hydrogen is going to have the similar carbon footprint as the current practice. So that is the one research where the process of the material by alternate reductant will reduce the carbon footprint of the vehicle. Then next one is about replacing iron with aluminum or aluminum alloy or composite material or similar to that. Surprisingly, the aluminum production generates more CO2 than a steel production on a ton-to-ton basis. For example, when I said the 3.2 tons of CO2 is produced when produce a steel sheet, aluminum is something about 18 tons per ton of aluminum. Of course, because of the low weight, the volume of aluminum required will be much less in the car. For if we say that 1-to-1 replacement, 800 kg of steel can be replaced with something about 250 kgs of aluminum. Okay, but then there are two ways to bring it down. One is that recycling of aluminum. See, what we are talking about is the extraction from the bauxite ore. But when the recycling of the aluminum with the renewable electrical energy source increases, this carbon footprint can come down. And the major chunk of it comes from the extraction of aluminum from the aluminum oxide to aluminum metal using the Hall-Heroult process. We know that in the Hall-Heroult process, we use the molten salt electrolysis method. where the alumina is electrolyzed to release oxygen and molten aluminum. In this process, I've actually see that see this electrical process. So again, if you can replace that conventional electrical energy source with renewable energy source, the major chunk of carbon footprint again comes down. So aluminum production is lucrative. But unfortunately, there is one practice which is being followed in the aluminum industry is that the anode what they use is a consumable carbon or graphite anode, where the oxygen evolved reacts to generate CO2 and it's extracted out so that it doesn't form aluminum oxide again. So when I say that about 12 tons of carbon footprint, I mean 12 tons of CO2 equivalent for a ton of aluminum extraction, about 3 tons comes from only the conversion of the graphite electrode into CO2. So this is where the material scientist part comes in. The temperature of the cell in the Hollerud process is something about 800 degrees centigrade. If a material, inert material, either metallic alloy or electrolytic oxide material can be developed, which withstands oxidation at 800 degrees, electrically conducting and oxidation resistant at 800 degrees, the carbon is completely eliminated. You have an electrode which is non-consumable and reduces the carbon footprint by 3 tons. And the rest of the electrical energy, if it's generated by a renewable source, my aluminum extraction from alumina has a 0 carbon footprint. This is a challenge for the material scientist to develop a material which is inert at 800 degrees for oxidation. This can be extended even for iron extraction. In fact, the only glitch here is the temperatures required will be about 1700 degrees centigrade. In fact, incidentally, this is the one of method NASA is considering to produce oxygen at Mars. You know, Mars is, we know that it's a red planet, and the redness comes from most of the rich iron oxide there. So one way they are considering to generate oxygen is that electrolysis of iron oxide to generate iron and release oxygen to the atmosphere. Far-fetched, but the challenge is the material. You have to have a material which withstands 1700 degrees centigrade. Oxidation at 1700 degrees centigrade. That's the challenge. But the near future, the immediate attractive, lucrative idea will be for replacing for aluminum production. So that comes from the material extraction part. Then the next part of, apart from the CO2 emission, the next major concern for the environment from the processing industries, metal processing industries, comes from the byproduct or the waste they generate. In the case of steel, it is mostly the slag, blast furnace slag and the steel slag. And in case of aluminum, it is red mud, which comes from which is dumped from the extraction of bauxite. Again, I think that AMPRI has done some very good work in converting the red mud for usable material, even for gamma ray absorption. And there are some similar projects I've seen where the slag is being used for the societal improvement, like for conditioning the soil and other things. So this is a bigger challenge all the time. See, the blast furnace slag is used in the steel, the cement production. So there is not much of concern about the blast furnace slag itself. The entire quantity is being used in the cement production for producing the cement. In fact, in JSW Vijayanagar site, they converted the blast furnace slag, conditioned it to mimic the river sand. So large quantity of the slag has been replaced, used in the construction industry to replace the river sand. So the blast furnace slag is not a big worry, but it's the steel slag which is of a major concern. We produce something about 200 kg, 200 to 220 kgs of steel slag for every ton of steel. And the problem with the steel slag is it has a very high FeO, very close to about 8 to 10%. And it has a good amount of calcium oxide, about 40%. but of which nearly 6% is in the form of free lime. So when it's used in the construction industry, what happens is that over a period it absorbs moisture, it starts swelling up. So people are reluctant to use this anywhere in the construction industry unless this material is aged. And aging this material is again, it becomes very expensive proposition. Either it takes years to naturally age in the normal rain and atmospheric thing, or you have to have methods where you are doing a steam aging, which takes about 2 to 3 days and expensive. But good thing is that it can be, if it is aged, it can be used in the construction, particularly the non-critical constructions like the paver block making and road construction, other things. But the presence of free lime in the steel slag itself is very good things. Like in olden days, when there was no cement, people used to use the mortar, which is basically a quicklime, mix of quicklime, sand, to build their houses. That most of the buildings, most of the palaces, what we see, are made with those. They have long lasting. The steel slag, except for the high FeO content, is more or less of the similar composition of the mortar. So when this is ground to -2 millimeter level, which is something like a sand, it can be used directly for a construction purpose. Nevertheless, not for a critical application like a pillars and load-bearing members. In fact, in as a part of the steel slag project at Vijayanagar site, they had done something called the hydraulic bound mixture for the road making. They made something about 8-kilometer roads, the internal roads, which carry the heavy trucks. So again, I would request, because there is already AMPRI is doing a lot of work on this similar line. This is one, the hydraulic bound mixture or the similar concept is the one which will help the industry to consume their steel slags. And involvement of an institute like AMPRI actually gives a broader base and better acceptance at the societal level. Okay. And the 300 million tons by 2030, the expansion dream, whether it happens by 2030 or not, that the future expansion of the steel capacity is going to be dependent on the ability to dispose the steel slag, which already been started by the Ministry of Environment, which is going to be, I mean, maybe made in a rule in a couple of years' time. So this is what the steel industry will be looking at the national laboratories to come up with. So there are like, I'm very sure that Tata Steel is also doing some work, but again, all the works are confined to the area nearby the steel plant. For the larger acceptance, we need involvement of the our national laboratories. With this, I'll conclude my address. I leave space for Mr. Udayan Pathak to continue on the lightweighting of the automobiles. Thank you.
Thank you. Thank you, Dr. S. and Manjini. It's a very interesting talk about the green environment. The subject you chosen was really wonderful. You talked about the waste utilization for the benefit of society as well as environment. You talked about the BSc norms, and you talked about the reduction of vehicle emissions. You have shared the various stages wherein the carbon emission take place, like raw material, extraction material, vehicle manufacturing, fuel cycles, and etc. Really, sir, it was a wonderful talk, and to talk about and to share about the waste, especially you focused about the two industries wherein a matter of concern that the waste is coming out, like blast furnace slag and the steel slag, as well as you talked about the red mud which has been taken out from the aluminum industry. Definitely, it's a great concern and a matter for all of us to take care of these waste so that we, by the novel processes, can convert these waste into the various useful material. And definitely, although we are doing that, we are expertise in this area, Sir AMPRI, but definitely these particular aspects also we'll see in the near future. We will be developing the novel processes and the product that will be useful for the society as well as to the environment, sir. Thank you so much once again for your nice talk and interesting talk, sir. Thank you.
Thank you.
Now to move ahead, ladies and gentlemen, our next speaker is Dr. D.P. Mandal. Dr. D.P. Mandal is Chief Scientist and Head at CSIR-AMPRI Bhopal in the Division of Alloys, Composite and Cellular Material. He is BE Meteorologist, MTech and PhD in Meteorology from IIT Kanpur. He has more than 28 years of professional experience at CSIR-AMPRI Bhopal. His research areas include aluminum metal metric composite, aluminum and magnesium alloys, metal forms, carbon forms, foundry, squeeze casting, biomaterials, deformation processing, technical tribology, wearing of material, as well as energy materials. He has received many awards, which includes Gold Medal, SAE Award, Rula Research, and etc. He has visited various countries like Germany, Rome, etc. He has contributed in his professional field as an President IIM Bhopal chapter. He has been the President of TSI, BOS member as well. He has guided more than 12 PhD students, and other students are still, he is supervising other students as well. He has published more than 170 research publications in very reputed journals and have 80 conference proceeding as well. He has been involved in uh, technology transfers of short fiber perform aluminum composites and has completed 25 projects which has been funded by various different agencies like Defense, DST, DOM, DBT, MOEF, MPCST, and other private industries as well. He has developed main technologies: aluminum metal matrix composite, fiber reinforced aluminum composite, short fiber perform, aluminum form ruler climatics, aluminum composite brake drums, dish, open cell aluminum form, carbon forms, and so on. Now, I invite Dr. D.P. Mandal to deliver his lecture on lightweight materials. Dr. D.P. Mandal, sir, please. Thank you.
Good morning, respected Director Dr. A.K. Srivastava, our respected RC member Dr. S. Manjeni, also presiding over this function, and Dr. Udayan Pathak, our RC member and the head R&D Center of Tata Motors, my senior colleagues and my friends. It's my privilege to express my sincere thanks to our director that he has given me this platform to discuss about what we are doing in CSIR-AMPRI in our division. I am heading the Alloys, Composite and Cellular Materials division, and we are working on mainly on the lightweight materials. And these materials has a lot of application in automobile sector and different sectors. In the area where we are working, if we see, we are working on the metallic forms, different kind of aluminum, steel, and titanium, nickel, and copper forms, both open and closed cell forms. Then high strength, wear resistance aluminum matrix composite, where the expertise around more than 20 years, and we have developed the process of making the aluminum composites, even the nano particle reinforced composite in a scale of 60 kg per heat. So we have that good facilities and expertise. Then corrosion and creep resistant magnesium alloys, that facilities we have developed, and we are now making without using any flags that magnesium alloy, and then its secondary processing like forging and rolling. Then carbon based materials, mainly carbon forms for energy sectors, as a stealth material for the defense sectors, and also for capacitors and other things. And other is the sandwich panels using metal forms, metal composites, and aluminum alloys and steels, and the FRP for mainly defense application and also structural application. The project we are presently working on those materials, and it has been sponsored by Department of Mines in defense sectors like ODF MEDAC, where also that DST also sponsored some project under Inspire Faculty project. We are working with Tata Motors, and now the CSIR also funding in some project to upscale the process of aluminum composites for defense, automobile, and engineering application, and also the magnesium alloys. Mainly its problem is corrosion and creep. So to develop the creep and corrosion resistance magnesium alloy, mainly for automobiles and defense. And also the aluminum foam core sandwich panel for aerospace as well as the automobile and defense application. We have developed the know-how for making these materials, aluminum composites, aluminum foam, carbon foam, and magnesium alloys. And our laboratory can work with other industry, and we are in a position to give the licensing of this technology, this know-how, and we can go ahead further to develop these alloys and these composites and foams. If you see that these alloys and composites and foams have a lot of application, mainly foams is for the crash as a crash worthiness materials, and it could also be used for the vibration and sound attenuation, also lightweighting of the materials. We have seen that if the foam is used as a core, there is a possibility of around 40 to 50% weight reduction for the sandwich panel or the foam filled tube. There is a need of redesign of the chassis or the door panels and other things if one used to use aluminum foam in the cars. And we found that there is a lot of opportunity to reduce the weight of the vehicles by using the aluminum foams. Aluminum composites, it can reduce, it can replace lot of steel and cast iron components in the automobile sectors. And we are mainly working on development of breakdown, break this, and connecting rod. And in this respect, we had already signed the NDA with the Tata Motors. Similar, we had signed the NDA with Tata Motors to develop the corrosion resistance and creep resistance magnesium alloys. And it can be used for the gear and engine casing, extruded seat frame, steering wheel, and extruded steering columns. Then carbon foams, it is the huge application for the lead acid battery, where it can reduce the weight of the lead acid battery significantly. But that lead grade will be replaced by the carbon foam grade, and which will be coated with the lead oxide, and then it would be used. And there is a lot of opportunity to reduce the weight of those batteries. And we are interacting with the foam making industry that is based on the Pune. Then multi-layer laminated functional composites for the armors, bunkers, and blast resistance panel. We are working with the ODF MEDAC. And we have in our CSIR-AMPRI has a strong group of simulation who can work from the designing to the material processing to the component development in all these aspects. And these are the industrial interaction we have. We have interaction with automobile industry like Tata Motor, Mahindra and Mahindra. Defense labs like DRDO, DMRL, CWFS, ODF, and other also that is GTRE and NMRL. Indian Navy and Mumbai Dockyard we are interacting. Then recently we have signed an NDA with Titan, only for the gold foam. Nordisk is for carbon foam, and Srishti Enterprises Bangalore, who are interacting with us for the aluminum foam. so that it can be used in the automobile industry. Then Indian Rail and Coach Factory, Kapurthala, mainly for aluminum composite and aluminum foam to replace the honeycomb structure. The aluminum industry like NALCO and also our NALCO that we are interacting, and different NITs, IITs and IIMs and other institutes in and around India and abroad, we are interacting, and we are have some recognition even in outside of our country, especially USA and Germany, for this material like aluminum composite, aluminum foam and carbon foam. Now, upscaling of the process and automation of this technology is needed, and we are confident on licensing some of the know-how in these areas. And if you see that we have worked on the carbon foam, open cell aluminum foam, which have lot of application in the AMI shielding as well as heat sink application. And these foams we have made through the reticulation technique using the PU foam as the precursor. And these shell size and all these things can be varied as per our requirement. The aluminum closed shell foam has been used to the crash box and bumper, and this has been tested at ARAI Pune. The fire resistance of these foams has been also examined, and these materials are very good for fire resistant application. And the blast resistance of the aluminum foam has been simulated. Through the simulation, we have seen that there is a great excellent scope of using the aluminum foam for the blast resistance application, mainly for the armored vehicle or tank and all these things. There the weight can be reduced by around 30 to 40%. Then multi-layer armor with the aluminum and titanium as the alternative layer, which can give the aluminum titanium interface, intermetallic at the interface, would make the material much having much higher ballistic resistance against the bullet. As far as our human resource depletion, we are very small group with the 6 scientists, but we are interacting with the scientists of other groups like simulation and also the metal forming and the metal processing division. So in total, we are working with the 10 to 12 scientists, and these are our other HR profiles. And this department has got award like Binani Gold Medal twice. We have got also 2 scientists, our senior received the Metallurgist of the Year of the award by Dr. Das and A.K. Gupta for this work in this area only. And the other award we have received. And as far as publication, we have a very huge number of publications in composites, metal foams, carbon foams, and magnesiums. And we have filed 15 filed out of that patents. We have filed out of that 5 has been granted. And as far as technology transfer, aluminum composite has been transferred to Messrs. Explosive Magnesium Private Limited, Hyderabad, and hammer tips for sugar mills to SN Welding Alloys Limited, Pune, and short fiber preform for making the composites through the squeeze infiltration technique, which may be used for development of piston, connecting rod, and all these things to Orient Siraul. Earlier it was Orient Siraul. These are the process we have demonstrated, and we are confident in making the product using this process. Our pilot scale production of preform mapping, we have made the preform as per the specification of GM, General Motor USA. And that technology we have given to Orient Syrup Limited. But it is within them that whether they can supply it to the GM or not. As far as aluminum foam, if we consider, we can develop our expertise, and we have the facilities to make aluminum foam of varying densities from 0.2 gram to 0.8 gram per cc, depending on our requirement and its energy, absorption capacity, damping capacity, strength, and all these things varies with the density of the aluminum foam. And now with our facility, we have established a automated aluminum foam making facility in batch scale up to 35 kg per crucible, and we can make 200 kg of aluminum foam per day. And it has the application in several areas, if we see. And the products like aluminum foam coat sandwich panel, then aluminum foam coat door panel, and also the channels filled with the aluminum foam we have developed. We have made the aluminum foam filled crash box and bumper assembly, which has been tested at ARI Pune. We consider the property wise, if we consider or compare, our foam is quite comparable, even sometimes better than the alu-like foam. And these are the tests we have conducted to see what is the level of strength, and all these things can be achieved at quasi-static condition and at dynamic condition. At dynamic condition, the strength of the metal foam is higher than that in quasi-static condition. That's it can be used for the dynamic condition used like crashworthiness, blast, and all these things. This has been simulated and then also tested parallelly at area. Pune have found that 400, around 150 gram to 300 gram or 3 kg of foam, 1.5 to 3 kg of foam in an automobile in the crash box and bumper can be quite sufficient to against the crash while the vehicle is getting accident at a speed of 55 kilometers per hour. So that can be used, but the cost would be increased. If we use the 3 kg of foam for a big car, there will be the additional cost of 6,000 rupees will be there. And that psychology of our people should be, they should be understand that what they are getting using these extra 6,000 rupees, that they should understand, because their car, their personal who are in board of the car will be much, much safer than what the money they are paying for the car. And it is that test we have conducted at ARI Pune with a simulated crash test, and found that the crash box absorbed the energy and nothing has happened to that assembly. But as that wall is very, very hard, strong, and all these things, so because of that thing, so some reverse speed is coming, but that reverse acceleration is much, much lower than what a man can withstand. These are the several applications of aluminum foam. It has a very multiple application in urban. While we are going to develop the electric car, there is a lot of opportunity to use the aluminum foam to make the electric car much lighter, so that the efficiency of the car can be increased. These tests we have, simulated tests we have done against the blast resistance, and found that if we use the metal foam at the core, the outer side of the metal foam, the acceleration or velocity and all this thing is reduced significantly. And this will have lot of opportunity to reduce the weight of the armored vehicle or tank or ICB used in defense. And that same philosophy can be used for the development of lightweight vehicles to use this foam in the flooring of the vehicles just above the chassis. These are the foam we have synthesized. It is the microstructure of this foam at CSIR-AMPRI, and now we have the capability of making this foam at a size of 150 mm to 150 mm, because that is the furnace chamber size. So we can, if we have the furnace with the bigger size, then bigger size foam can also be made. This is quite reproducible, and its cell size can be controlled by controlling the cell size of the precursor, and the strength and all this thing can be achieved by controlling the pore size of the foam. And this aluminum foam has tested, and it has got the properties, thermal conductivity, and all this thing has been tested. And if we go for the as-is relation, then we found that these values are quite correct as per those relations. But we can think that thermal conductivity is low. But if we see its surface area is around 300 to 400 meter square per gram. So if that is there, then extraction of heat, effective extraction of heat is increased significantly. That's why this foam has a lot of opportunity to be used for the heat sink. That aluminum composite breakdown or the magnesium alloys have several applications in the automobile and also in defense like missile and or the aerospace structure. But we have the capability to make these alloys, composites, and the foam, and we can have a lot of collaboration with the industries to make them successful for some commercial use. This is the way of the aluminum composite, and even the very fine particles, nanoparticles, carbon nanodot or graphene, we have dispersed uniformly the aluminum matrix, and it gives significant improvement in the strength, around 40% improvement in the strength over the alloy just by adding 1.5% of CNT or graphene, and it can be successfully rolled also. So that for that we have done some modification to add these carbon nanotube or graphene or nanopowder within the aluminum alloys, and that process, that technology is quite reproducible, and we have seen that the property what we are getting, that is almost through the addition of nanoparticle around 50% over that of the coarse particle. And these composite, even with a particle size of 10 to 15 micron, it can be rolled successfully. And after rolling, if you see, that is the coarse particle aluminum CNT composite, its strength after rolling reached to 554 MPa. And this is quite, I think this is quite equivalent to a steel of around 150 to 2000 MPa steel. And the expertise we have for doing some texture and EBSD analysis, and also the deformation mapping we can do, and we have done the deformation mapping. From there we have optimized the process parameter, and then we have done the rolling of the composite by using the optimized process parameters. From the designing of the die to the manufacturing of the component, that is breakdown under the project of development of aluminum composite breakdown for Tata Motors that we have done, and we have the expertise in all these areas, the designing of the component as well as the solidification, modeling, die designing, and pressure die casting of these materials. The new area where we are working now, the development of hollow sphere balls, which can be used for making the syntactic foam, as well as a hybrid foam which have a closed balls that can give you the closed porosity, as well as the in between the balls there will be very fine pores which are interconnected, and those kind of foams can be made and which have much higher energy absorption and much higher blast resistance capability. It will be used also for the sound and vibration analysis. But the main problem is the cost of these hollow balls. Now it is very much costly. Now we are now trying to make these process cost effective to make the hollow balls so that this can be used for making the syntactic foam for various applications. Here is the magnesium alloys. We have the facilities of magnesium alloy preparation through the use of SF6, CO2 and atmosphere. But this process has been modified. Now we are without using any gas, only the inert gas. And we are not using any flux, just only using the inert gas. We can now make the magnesium alloys of different chemistry, that using different transition element as well as the rare earth element to improve the strength of the magnesium alloys. The developed alloys were also rolled to very thin sheet of 1.5 mm thickness. That is the facility we have, because using our facility we cannot go beyond that. So after rolling, we have got the strength of 174 US yield strength and 271 UTS. So it has the quite good opportunity to use in the automobiles, but we have to see the corrosion resistance mainly. That's why we are now going to see the anodizing, to apply the anodized coating on the magnesium alloys and then to see its behavior for the corrosion as well as the creep resistance. The magnesium alloy composites that we have made, and if we see that even the fine or coarse particle, it can be dispersed in the magnesium alloy more uniformly than what we can do in the aluminum alloy. Because magnesium has the better reactivity with the ceramic particle as compared to the aluminum. And thus, this work we just initiated, and we have done the hardness measurement, and we have seen that hardness of the alloy improved by around 70% by using the 10% SiC within the alloy. So that's why its strength and all this stiffness can be increased significantly by using the ceramic particle within the magnesium alloys. This is the carbon foam we are making using the same methodology what we are using for the open cell aluminum foam, and we can get the carbon foam with the different pore size, with the different strength, porosity, electrical conductivity. It may be varying from 140 to 160 in this range. Then thermal conductivity, surface area, and EMI shielding. And these foams can be used for the battery application. That lead grid can be replaced with the carbon foam. And then its weight reduction will be significant. And some battery making industry that know this, they are interested, and we have given some samples, 150 mm into 150 mm to those industries, and they have evaluated. And some of the properties they have said to us that, oh, it is quite acceptable by them. Still, they are now evaluating for some other properties. So this is under evaluation by them, and this carbon foam can also be used for the electromagnetic shielding for the defense vehicle or aerospace in this year. Because out of the 60 dB of the 80 dB of the EMI shielding, its absorption is around 70 dB. So that's why its absorption coefficient is very, very high. So it can be used for the steel technology. And that why it is giving the strength is because of the multiple scattering of the EMI, that wave, and because of the multiple scattering, the radiation is reduced and absorption is increased significantly. And these are the some work what I already told, that multiple layer of aluminum, titanium for the ballistic resistance application for the armor. And we have seen that 8 mm thickness of this steel can resist the bullet at a speed of 800 meter per second. That we have already tested. And this is the things we can, now we are working in this area, that aluminum foam core sandwich panel with the ceramic at the front, aluminum alloy at the back for the armor application, as well as the blast resistance application. Another area is the polymer matrix and polymer matrix composite. We have an excellent facility, excellent expertise of our scientists, and we have developed number of components for the BHL. Even that presently we are working also with the bamboo composite, and this technology has been transferred to the some of the Bhopal-based industry who are regularly making these materials, and they are one of the largest polymer industry in India. And the other is the hierarchical composite aluminum carbon fiber reinforced hierarchical polymer composite, fiber reinforced composite. And here our objective is to increase the strength as well as avoid the debonding, and that has been successfully developed, and this has a lot of opportunity to be used in automobile, particularly for the lightweighting of the automobile and also the aerospace structure. And in conclusion, if we say that we have demonstrated number of process, products, and materials which can have a lot of capability to lightweighting of the automobiles or aerospace structures. The futuristic materials AMPRI is well recognized not only in India and internationally. In some of these materials, AMPRI may be the only lab in India who are working in this area, especially the carbon foam and also the aluminum foam, the open cell metal foam, and even in the aluminum composites, maybe in our level, some other, maybe the NIST Trivandrum, that is also a CSIR lab, they are working. But in large scale, the AMPRI is working only in the aluminum metal matrix composite. And then also the magnesium alloys, some HAL was working, but now, and after that, AMPRI has started and they have developed the facility. Means in all the above area, what we have to discuss, the AMPRI may be in the front in India. And we can collaborate with the industries. We have explored our expertise, fertilities, and the knowledge base data what we have created that can be explored for the commercial exploitation with the joining the hand with the industries. Industry like Tata Motors, maybe, or Jindal's, maybe our strong collaborator. I want to say another word that the steel slags, that what we have done, the cupola side, that we have used, and there is we have seen the feasibility study we have made, that this can be used for making the flooring tiles, as well as 50% of these slag can replace the cement. Suppose we have to ground it, and 50% cement and 50% of this slag, if it is used, that will be equivalent or even better than the Portland cement. So that we have seen and we have tested, and that in small scale facility, lab scale facility, we have developed those tiles also, and these have a very good properties, hardness, even the very low moisture absorption, all these things we have done. So we can also collaborate in this area. Thank you. Huh?
Thank you. Thank you so much, Dr. Mandal, for your nice talk. You talked about the lightweight materials, especially for the automobile applications. You have shown the excellent expertise and the facilities which are available here in the AMPRI, wherein you have developed these type of materials. You started your talk on the aluminum closed cell foam for the crash and blast for the armor vehicles, wherein you said that the weight can be reduced by 30 to 40%. You also talked about the aluminum and titanium metallic forms. You shared the detailed technical data about the crash test, empty or foam-filled crash box, wherein you showed that the crash box absorbed the energy and nothing has happened to that. It's really wonderful. Several applications of aluminum foam were also discussed by you, and you have talked about the simulation of foam, core sandwich panels for blast furnace, open cell aluminum foam for thermal and catalytic application was also discussed by Dr. Mandal. Aluminum matrix composite and other things were also shared. He has shown the expertise in the designing, modeling, stimulation, processing, and developing the products. Say several products he has shared, especially the hollow metallic spheres, high strength magnesium alloys, lightweight carbon foam, multi-layer composite for armor application and bullet simulations, advanced carbon fiber composite, hierarchical CFRP, bamboo composites, technologies, and so on. We are really impressed, and we are sure that by this expertise and the product that we are developing here in the AMPRI, definitely the society will be benefited, and the near future, all these products will be going to the society with the help of the industry. Thank you so much, Dr. D.P. Mandal, once again for the nice, interesting, and very knowledgeable talk. Now, ladies and gentlemen, to move ahead and to call my next speaker for the talk, let me introduce you with him. He is Engineer H.N. Bhargav, a Senior Principal Scientist at CSIR-AMPRI Bhopal, Head of Intelligent Materials and Advanced Processes. He is an ME, Electronic and Communication Engineers. He has more than 2 decades of R&D experience in the field of applied research and development. He is an expertise in the field of smart material-based actuator development, control, signal processing, aluminum-based actuators, and instrument development of different fields like medical, safety and security, analytical instrumentation, prosthetic and automobile industries, etc. He has more than 6 national and international patents in his credit and have several research publications in various reputed journals. He has also been involved in transfer of 2 technologies to the industry for commercialization. He is a pioneer in the field of software packages, SDK used in project development, MATLAB 2018 with image and signal processing toolbox, LabVIEW, Vision Assistant, standard image processing libraries, Neuro Solutions, hardware were used for the development of the projects, national instruments, and so on. Ladies and gentlemen, he has completed various R&D sponsor projects by different agencies. Some of them are development of artificial intelligence control linear displacement actuator based on thermoresponsive smart materials, lightweight shape memory alloys via actuated prosthetic hands, shape memory alloy actuators, portable reading machines for the blind, handheld scanners, and the list is too long. He has been also involved in the networking, internet and internet facilities installation and commissioning at various other lab also. The list is very long of his achievement. Now, not taking much of the time. Now, I would request our next speaker, Engineer H.N. Bhargav, to deliver his lecture on smart material actuators. Dr. Bhargav, please. Thank you.
Sorry. I just unmute myself. Thank you, Dr. Sarika. First of all, I would like to be my very warm greetings to respectable chief guest and RC member, Engineer Udayan Pathakji, DGM Tata Motors, and respectable RC members and special chief guest, Dr. S. Manjini, Associate Vice President, JSW Steel, my respectable director, Dr. A.K. Srivastav for giving me an opportunity to be present my department work in front of all the renowned steam gathering here, distinguished dignitaries across the connected across the online platforms. My namaskar and good morning to you, all of you. Let me share my screen first. Okay. Okay. I think so. My screen is visible to you. Before I move to my lecture, my topic of the lecture is smart material actuators at CSIR-AMPRI. These are the few devices, actual prototype we have developed at AMPRI using the smart material and for use for various applications. We have to discuss about this actuator in my later subsequent slides. Before we move to these actuators which are developed here, I would like to discuss, give a brief glimpse about the sensors and actuator, why it is so important for any autonomous system. Sensor and actuator are basically the 2 points of the face. We can say without sensor, actuator can't do it. Similarly, the actuator can't do without sensor. That's how we call the transducers. So these are the class of transducer where both the things must be required for any kind of automation system. Without them, it cannot be possible. Just like a sensor has a property of that, it converts the physical domain, physical information to an electrical signal. Just like here, we can say the sensor gets the inputs of physical domain and then process it to convert the electrical signals. As well as the actuator is just a reverse procedure here. It takes the electrical signals and convert to an physical output in the form of actuation. So these two things are very much essential and important for any kind of automation system. These actuator, I discuss about the actuator. Actuator basically at the end result-oriented devices, which could be useful for any kind of actuation purpose. These actuators are basically divided into 2 categories. We can simply call as the linear actuators. We can simply call as the binary actuators as well as the continuous actuators. Binary actuators are simply just like a two stable state. This 2 stable state does not require any stable power maintained for this state. Does not require any power to maintain these states, because while transforming transformation from the one state to another is need only power. This guy just like our switch. We can do the switch or releasing the switch or actuation the switch. These are the only binary actuation. These are the most important kind of actuator for using and taking the decision by any actuation or any work has been completed or not. Similarly, other is a continuous type of actuator. These actuators require a continuous motion, and during this continuous motion, you need to be controlled. System should be robust, rugged, and then also need a continuous power required for maintain the continuity of this actuator. These are the 2 broad class of actuator. We at AMPRI Bhopal had developed these 2 kind of actuator for using safe memory for various applications, including automobile as well as other applications. Before I move to my actuators, AMPRI actuators which are developed here, I would like to discuss about the safe memory alloy. Safe memory alloy is a smart material. It's a class of a smart material, where it is a two material are joined together to form the alloy. Is a nickel and titanium. These two materials blend together is form the alloy. And this alloy has a property it provides two stable states. We can call as acidic phase and then metastatic phase. These are the acidic and metastatic, but there's two stable states. During this transformation of this material, it is going to be store the strength which generated by external force, and then while we apply any thermal or electrical thermal or stress process, it's going to release this strain in the form of displacement. And while releasing the strain, it produces a lot of stress. This stress could be used for can be used for our actual purpose, for external mechanical work. That's why this property, these properties of this smart actuator would be useful or very wide useful for actuation purpose. Meanwhile, it also has some electrical property. While actuating by an electrical or joule heating method, it has a change of resistance while transferring from two parent phase. We can say ascending phase and metastatic phase. These two parent phases are transferring from one phase to another phase. It has a change of resistance. If we can properly extract this information or change of resistance from metastatic to ascending or ascending to metastatic, that's why it gives the information of their position. So that's why we can use this actuator for both sensing and actuation together. This is the very blend of this kind of material which are having the property without need any external sensor. It provides the actuation with high force with lightweight. That's why this kind of material can be used for future kind of applications, just like our distinguished guest who's going to be deliver lecture on lightweighting opportunities. That's why this kind of material can be very, very suitable for such of application for automobile industries. Here I just want to give the little bit information about that, how this is going to be worked, because initially the safe memory alloy is in the metastatic phase. We call the detuned metastatic phase. When we apply the stress, is going to be tuned metastatic phase. And that's why this is going to be store the strain information in the deformed metastatic phase. When we apply the heat, it's going to be transferred to parent phase, which we call the parent phase is called the acidic phase. As the temperature goes down, it's cooled down, it returns back to the parent positions, metastatic phase. It also have a two properties. This complete property is called the safe memory effect of the material. Similarly, it also have another property which we call the superelasticity. Superelasticity property has been observed at the high temperature. It's the parent phase of the acidic phase, we can say. In the acidic phase, when we apply the stress, it's going to deform to the metastatic phase, and as the stress is going to be released, it returns back to the acidic phase. These are the information, or these are the properties of SMM material can be used for various different applications as well as in the automobile industries. Before I moving to the development part, I would like to give about this property. Basically, it has a power to weight ratio here, and then weight. Because it is very lightweight, we can say this is fall into this category. It is a low weight, we can say around maybe the 5 grams or 10 grams, and it generates the power 10 to the power 10 to the 4 watt per kilogram. This is a huge power has generated by the small amount of weight of this actuator. But it also has some limitation, but we can design a proper actuation system. It has a not limitation, it has a limitation of bandwidth, but its actuation speed. That's why it has to be it limited themselves in the range of 10 hertz, not more than this. For higher application, definitely this kind of actuator is not suitable. But for the lower applications, it can deliver the very huge amount of power or stress to the net with the limited bandwidth. This bandwidth can also be improved with the help of suitable mechanism. We can solve the spring bias or the interference configuration, as well as the robust control mechanism to compensate this hysteresis property. So this is the versatile material for using for the coming days for the any kind of application purpose. Here in the CSIR-AMPRI, this department is going to be work for various R&D activities, in which I just wanted to just give the brief highlight about that SM actuator. We had developed the SM actuator for 3D printers for micro displacement. This kind of continuous kind of actuator for that. Another actuator we developed for prosthetic hand. This is also a movement of fingers and then to grab any object by the human being. This actuator has been activated by the EMG signals from which is going to be connected by your amputated hand. Second, thirdly, this kind of actuator can also be suitable for orthopedic rehabilitation devices, which is either in the binary kind of actuator or in continuous kind of actuator. And the most important actuator is the automobile or actuator automobile industry. Initially, we have targeted to deliver an actuator, to develop the actuator for the door, central door, lock and lock system, filler inlet lock as a petrol lid opener, unlatching system, trunk or trunk lock actuator system, which is in the form binary system, because these are the required binary system. You just only have latching, locking, or latching or unlatching the system. So this kind of actuator, it needs a sophisticated electronic system. So that's why we have a very good facility to develop the electronic system for heating mechanism, because actuator need a sophisticated heating mechanism system, control mechanism, instrumentation and automation of the particular device, data acquisition, because before any sensor or actuation cannot do without the data acquisition. We have to acquire the data and pre-process, post-process, and accordingly develop the algorithm for actuation purpose. These are actuators either in the PC base as well as the microcontroller base. We have a capability to develop the external controller to deploy end-use applications there. As you know that as shared memory alloy has a non-linearity and hysteresis property. So that's why if we can be able to enhance, remove this non-linearity and hysteresis property using the artificial neural network or machine learning technology, the machine learning does not require any mathematical model. This model has been trained, or inherent model has been trained by change of resistance as well as the strength. So this model or this AI model has a property to approximate the function based on their learning pattern. And this pattern directly can applicable to our end applications. This is the combination of neurofuzzy as well as the linear PID controller. As a simple linear PID controller can be used for the controlling mechanism. Another application, another area we are presently focusing this department is the smart material development based on copper, aluminum, magnesium alloys. We are also developing the smart material using this best combination of copper, aluminum, magnesium. We are also working on a thermal battery to store the thermal energy or sun energy, to trapping the sun energy in the daytime, and this energy can be used for when the sun is not available or during the night time. So that's kind of application also be here. Electromagnetic forming and joining applications here. We have a good facility here, which going to be joining and forming the product or component for automobile industry, as well as waveguide designing a space application. We recently finished our one of the good project for the waveguide joining for the space applications. Before this is my department activities, but I would like to emphasize here this kind of material very suitable for the actuator application. That's why which are the four basic areas, basic points where we have to focus to use this material for the automobile industry. Headlight setting, just like we have to move the headlight according to the direction or setting for high beam to low beam, or far distance or near distance. Mirror setting, automatic mirror setting kind of actuator. Dashboard actuators, door locking, belt retractor, brake clippers, shock absorber setting, trunk lock, seat belt, inside many more applications we can target this actuator. But initially at CSIR we are targeting three applications, which is more easily controlled and easy to deploy any automobiles. Before to develop this kind of actuator, we need the first requirement based on how much the power, displacement, and that's why design challenges must be required. That the displacement, power, and speed, at what speed we to control mechanism has to be developed. What are the operating conditions, size to fit, or their mounting size, actuation type, what kind of linear type or the binary type or continuous type. Similarly, the design specification we also need it. The materials, loading condition, form, type of wire or form or design, various kind of shape and size, design types, controlling mechanism. Now, after these are the requirements fulfilled, that we have to model out and prototyping the machine and then testing and evaluation. This is the method and device how to develop our actuators for that. And these are the steps we have to follow for developing our own actuators recently, which are going to be demonstrated or discussed in the next slides. Sorry. Now, the shared memory actuator developed here at all. Basically, we are just, I have discussed in the previous slide, we have developed three actuators, which we can call the fuel lead and latch actuator. This is a very common kind of actuator for the user and right now the available in the automobile or car. These are the two levers are present in below the seat of the driver, from where the driver is going to be pull this lever and then opening this lead, petrol lead, as well as your bonnet, trunk of the car. So this is the simple mechanism, but we can also be automated the system with using the very small actuator which we available which we have for right now. So this can be fitted here. We just have a simple mechanism, simple electronic, and these are the properties of this actuator which is going to be suitable for this controller. Similarly, for door lock, unlock actuator. So right now we're using the central locking mechanism using the DC motors. This DC motor, which is going to be a solenoid motor, which is going to be provide the pulse by our key. The key has the two keys in our ignition key has the two buttons there. The open and close of the opening and closing of this device actuator central locking system. Similarly, we can replace only the gun, and the same controller can be lying there, and it will going to reduce the weight as well as the four guns can be replaced by our actuators, SM actuators. Similarly, for trunk unlatch actuators, these are the actuators can also be fit over there. These are the actuator has been tested by the Desire car of Maruti as well as the Maruti 800. We have to put it there, and then this is Zen car where we have to use this petrol unlatching mechanism right now. This technology has been patented by us in this time, and we applied for patenting that. These are the video demonstration I would like to present in front of you. This is the actuator has been put in my own car in the Maruti. We are going to apply the electrical current. It's going to be unlatched. Right now, the dicky has been locked, and it is going to be unlatched. We just only apply the pulse, and the response time of this complete system is around maybe 1 to 2 seconds. So we have improved this things, and it can be improved further if we can find the suitable collaborator industry with that we can modify it and according to change the design. We don't want to change the existing using latching mechanism. We just wanted to modify the existing system because the end applications of this actuator cannot be provide the house mounting different mounting space at the different situation there. Or we do not want to change the existing mechanism. We just wanted to superimpose our actuator over the existing system. That's why there is no need to change their die and the manufacturing process design as well as. Similarly, this actuator also be mounted on the door, just like you have to close the door, and we apply only the single control button, just like you pressing to close the button. The heating mechanism, as you apply the pressing mechanism, the heating pulse is going on there, and then it is going to be lock the door. This is the door has been locked by this control mechanism, just like our central locking mechanism has there. And now we tried, it's not going to be open. The similar way, we have to unlatch it. We have provided two push button switches there. It can provide the heating mechanism pulse to the control mechanism, and it's going to be unlock the system. This is right now presently the device. The actuator is very big, but we have to replace a very small amount of, we can say 40 to 60 mm or that's size, and then mounting capacity over there. This is basically a working prototype here. We are going to be demonstrated here. This prototype is lying within our laboratory also there. Now I move the similar second application for the SMA kind of SMA actuator for 3D printer. In this project, basically what we had did it, the 3D printer has a printer head and as well as the print pad. The print pad and printer head having a aligning mechanism. The distance between the print pad, the distance between the print pad and then the print head should be have to maintain the distance, and the distance cannot be possible at all constant throughout the printing process. That's why this is a continuous kind of SM actuator. It can be used for automobile industry for require the continuous motion forward and backward for the, we can say the blowers, lowerers in the AC vent there. We can also move the vent there direction forward and backward direction. So this kind of actuator can be suitable for that. We can just simply little bit modification and accommodate the things or the automobile industry. So this is our application, and then specification from where it can also be moved to lift the load of 500 grams with having a number of elements in the forward and backward direction, and it provides the actual stroke length around 5 mm. This also technology has been applied for patent. This is the characterization technique which we did it, and I just wanted to give the glimpse of this video. From where this is the 5 mm displacement, we apply the electrical pulses. This is the motion there, which will lift the load around 100 grams, and then this is nicely lifting the load 100 grams opposite the gravity, and confirmed in the length of a stroke length around maybe 5 mm, 4 mm. So this is the very good application for that, for continuous motion. This is the actuator we have been mounted on the SMA 3D printer, where the nozzle is going to be moved forward and backward with the application of the control mechanism. Here, we do not put any kind of sensor, external sensor which is going to be sense the physical position. This is the motion is going to be here where the print nozzle, from where the print material has come out with the molten state and is going to be print. This actuator is going to maintain the distance between the print bed and the actuator itself. So this is the actuator which we have a capability to control in both the direction, forward and backward direction. This is the characterizing process there. We have to do a characterization in our laboratory, and this is the beauty of this project. We can say we have to reduce the hysteresis by applying the SMA wire in back-to-back condition. As you saw that we can find very small amount of hysteresis gap between the forward change in resistance as well as the displacement. So this is the control mechanism is going to be subsidize us. We can directly apply the simple linear controller to control this SMA actuator. Without this mechanism has reduced the hysteresis weight. This is the control property there. We can accurately control with the physical load. This is the test which would enter the fatigue like test. How much the length is going to be work. How long it's going to be work for that. We have tested around maybe 50,500 seconds for the continuous motion forward and backward. Another applications of the SM actuator for the prosthetic hand. The heat is also the continuous kind of actuator there. We can develop the actuator for the prosthetic hand and it's working well. I will give some video demo for that. And this is also the SM actuator can be utilized for any other application, not limited to the prosthetic end. We just said, but because this is the actuator, we have to test it for this particular application. That's why I giving the example here. But this is the actuator can be versatile for any kind of macro position or continuous motion. For anywhere in the application is required. It has a limitation of speed, but we can improve the speed to that. This is our video demo for that. We have to mounted here the SMA actuators in the linear direction. This is our CAD model, which is going to be moving the fingers forward and backward direction as they're going to lift the load of the particular things. And this is the two fingers we have to merge together and apply the control mechanism by the PC. Third, another applications we have to develop the SMA material for the development of copper, aluminum, and manganese base, copper, aluminum, and nickel cadmium base. We have to increase the transfer temperature, decrease the transfer with the addition of the zirconium as well as the chromium. These are the two characterization of this material, which is going to reduce the transfer temperature by using addition of zirconium as well as the chromium. This is also good. We have in-house develop our SMA actuator, and it can be used for high temperature application also. This is one of the wonderful application. We can thermal battery for energy storage, which we call the latent heat thermal energy storage system. From where this is the special phase material, from where it has a very bad conductor of the heat. It cannot be absorb the heat. That's why we have to put the heat from the sun. It trapped down, and using this material, it can going to change their phase, and it can retain their energy up to 140 kilojoule per kilogram. And it can be used for later on in the evening or in the night purpose. But we have to increase the thermal conductivity. We use the aluminum wire foam to increase the thermal conductivity. And this can go to inside there and deep inside there and increase the volume, surface volume, to absorb the thermal energy from the from the sun in the form of either by the photovoltaic to convert the electrical energy to heat them. And this heat energy has been absorbed or stored for the longer time can be used for longer any other purpose. Just like we have to improve the thermal energy by without the aluminum foam or with the aluminum foam. This is with the aluminum foam, it is going to increase the thermal energy, and without the aluminum foam, the same energy can be also recovered by using the heating the cold water. This is we can go up to the 200 cycle minutes to extract the energy from which is trapped inside the thermal battery. These are also the similar kind. So that's why we can conclude that the thermal efficiency of the latent heat thermal energy system can be increased 1.5 to 2 tons by using this as a aluminum wire. This work has been published in our reputed journal. This is a journal which is having a good impact factor around 3.7, and it could be the future application for any kind of energy storage purpose anywhere. Another facility which we have in our department is electromagnetic forming and joining. This facility is very versatile, very useful, clean process, motival, stable, and joint property, better joint property of dissimilar material also. In this case, we can say the huge energy stored in the bank of capacitor can be discharged across using the coil, which is going to be deform any object in the form of die, which we have to found that this is the facility which we have in our department that has like the 2 racks of the capacitor bank, control bank, and then console by the user. This facility can be associated and develop the number of components for the automotive industry also. Some of the broad applications that defense strategic automobile, there's a automotive fuel filter there, shock absorber, dissimulator merging, the dry shot there, dissimilar tubes, as well as the lugs for the high current or high voltage applications, and then seat pedal forming. These are some few examples there. We have to join together or weld together with the using of this technology by copper, aluminum SS, aluminum copper MS, and these are the numbers which we had in non-conducting property. But we can, because as you know that the joining of two disciplines have a difficulty by the conventional method. This is the methodology is very suitable for joining of two dissimilar materials. We have recently completed one of the project for the communication application. We have to join the two waveguide together, because joining of two waveguide will require a flange of heuristic, and the flange weight is going to increase the total weight of the system for the communication purpose. So that's why if you're going to use this technology to reduce the weight of this waveguide, these are some microstructures, SCM images of the structure which simply diffuse to material in the seamless manner. Last but not least, I would like to acknowledge my director. I would like to express my deep gratitude to my director, who has given me the opportunity and their continuous support, guidance, and encouragement during the use of this project. I would also like to express my sincere thanks to my fellow scientists who have given me entirely support during the execution of this project, fellow scientists and funding agency and the collaborators. Thank you for your patience listening and for your kind attention. Thank you.
Thank you.
Thank you, ma'am.
Thank you so much, Engineer H.N. Bhargav. You have beautifully explained about the sensor and actuators. You have started your talk with the basics of sensors and actuators, their importance, and how they are working. You have talked about the shape memory alloys, different type of phases, S13 and Martisan you have shared. You have shared that how smart materials actuators are developed and they can be used for various applications like 3D printer micro displacement, prosthetic hand, orthotic rehabilitation devices, automobile, etc. We also talked about electronic system development for smart material actuators, AI-based prosthetic, thermal, battery, and electronic forming also you have talked about. Wonderfully, you have shared the achievement and what we have done here in the AMPRI about the three main SMA actuators. Beautifully, in your talk, you have shown the videos that really demonstrate the practical innovation in scientific has been applied to use this material. Fuel lid unlatch actuators you have shown door lock unlock actuators, trunk unlock actuators also. To proceed further, there were also content about your electromagnetic forming and joining, its methodology, process, applications for defense, automobile, aerospace, nuclear, home appliances, powers, many more things like thermal battery for energy storage for SMA material developed. Really, it was a very wonderful and very practical talk, and wherein we can see that how beautifully you have shown in all your videos that by using the scientific and technological interventions, we can develop many more advanced material, and in the near futures, with the help of the industries, we can give it to the society, and definitely the society will be benefited, and these materials will be useful in different applications. Once again, thank you so much, Engineer H.N. Bhargav. So, ladies and gentlemen, to proceed further, now it's a proud privilege for all of us, and it is an honor for all of us. We have an eminent personality with us, Engineer Udayan Pathak. I would like to share and thank you so much, sir, for let you know that along with distance he has crossed to visit here in the AMPRI and to celebrate this National Science Day with us. Thank you so much, sir, for this. To start with his keynote lecture on the electric vehicle evolution and lightweighting opportunities, I would like to share his brief achievements, what he has done. His achievements are actually very, very long, and which are really again to put into the words in short of few duration is difficult, but still I'll share his detail about him achievements. Meteorology from VNIT Nagpur, and he has about 4 years of professional experience. He is presently, as we have already shared, but I let you know that he is an DGM Engineer Research Center, Tata Motors, as well as RC member at CSIR-AMPRI Bhopal. His basic responsibilities for conceptualization, designing, and implementing IPR protector engineering world-class quality framework, which is leading to the world-class engineering. He has also worked on non-conventional material concept like thermoelectric materials and vehicles, lightweighting, photovoltaic materials, computational metrology, Center for Excellence for Tribologies, fogging, and functional fluids, VA and VE. He has been received various awards and fellowships in his career. He has been the winner of Best Paper Award. He has been the nominee for Distinguished Alumni Award at VNIT. He has also been awarded with Ranendranath Datta Memorial Award, and many, many more awards is there in his credit. Now, he has also started his career as GET in Ruston Horns and has worked in the John Degree Equipment Private Limited, Automotive Casting Group DGP Hindoi, Spicer India Limited, Bharat Forge Limited, etc., and all other companies. He is well known in the area of development of field-hardened crankshaft, piloting of polymer quenching in India, substitution of alloyed steel by lean steels and SG iron, reducing global cycle of nitrating from 72 to 24 hours. He has done the successful implementation of hollow construction for automotive lightweighting. He has traveled various countries like US, Germany, and Norway for various R&D works for the presentations, new technology evolution, and all other things. He has been also associated with other professional responsibilities, like he's been a chairman at ASM, American Society of Materials, and also during his teenager at the Pune chapter was awarded as 5-star chapter for world-class performance and chapter of excellence award for best chapter in the world. Congratulations to you, sir. He is an also member of consortium member on vision document and roadmap for light materials usage for automatic applications. He has been the member of Indo-Norway and Indo-Australian Lightweight Consortium. He has more than 16 national and international patents in his credit and has more than 2 dozens of publications in the reputed journals and in the areas of induction hardening, gas nitriding, environmental quality system, intensive quenching, technical education, lightweight, failure analysis and foundry, thermoelectric materials, and electrical vehicles. He has also been the visiting faculties in various institutes like COEP, VNIT, RIT, AICT, etc. He has also been involved in Indo-US initiative for improving technical education, Norwegian Technical University, and so on. The list is very, very long. So, ladies and gentlemen, now I'd like to invite our chief guest of the day for his keynote speaker, and he'll be delivering a talk on a very, very interesting topic that he has chosen for all of us in this very special, auspicious occasion of National Science Day, that is electric vehicle evolution and light weighing opportunities. So, I invite you, sir, please. Thank you, sir.
Thank you very much for such a nice introduction, Dr. Verma. Thanks the team AMPRI and particularly Dr. Avnish Kumar Srivastava for inviting me to deliver this small experience, whatever I have, and trying to put what are the challenges we are facing in electric vehicles. So before I start, a small disclaimer that opinion expressed in this presentation are my personal views and opinions and may not be necessarily official views of Tata Motors Limited. This is going to be the content as how I'm going to speak for about next 30 minutes that has been given to me. Talking about the automotive industry today, the Indian automotive industry is 6,500 billion rupees. The contribution to Indian GDP is 7.1%. Contribution to manufacturing GDP is 49%. Of course, these are the numbers which I am telling pre-COVID. Probably some of the effects of COVID has not been captured in these numbers. We are the largest tractor manufacturer in the world, second largest two-wheeler and bus manufacturer. Yeah, I think some technical adjustment has to be done. Yeah. On the heavy truck manufacturer side, we are the 5th largest in the world. Car manufacturer, 6th largest. And these are the kind of thing. As far as the employment opportunities are concerned, for one truck, you get opportunity of about employing 13 people, 1-3. For one car, 6 people. For three-wheeler, 4 people, and two-wheeler, 1 person. This includes the total right from the manufacturing till servicing and end of the life kind of thing. Very diverse number of vehicles and diverse cost of the vehicles are available. On one side, we had Nano, which was costing 2.26 lakhs on the road. On the other side, Jaguar F-Type, which is 3.27 crores. So a mix of vehicles available. A difficult kind of usage pattern. I mean, most of these things are very common in all of us, to the extent that if I show you the next picture, which is not the reality, but you will still believe this. This also can happen in India. On the off-highway, or if I talk about tractor industry, this is going to be the picture. This is the tractor which is used typically on the Andhra Pradesh and Karnataka border, where the rear tires are replaced by steel cage, and this operation is called puddling. You can see the kind of operation that tractor is doing. It is making slurry out of the mud and water to make it farm ready for the sowing of the rice paddy. Again, this is not specifically done only for the video shooting, but this is the regular usage pattern. 90% of the tractors in that particular zone or in that particular rice belt are doing this kind of operation. And in terms of engineering application, it puts a lot of load onto the differential systems, and a lot of failures are occurring into that area. So again, I will just, in the interest of time, I will cut short this video and move to the next. This is some of the production data for Indian automotive industry. Again, intentionally, I have skipped the COVID period. and I'm showing up to 2019, you can see there is a steady increase in number of vehicles constantly. Also, there is a paradigm shift in the customer thinking that automotive industry is going. Earlier, we were talking about only transportation. Now people are talking about the mobility solution. People are talking about shared mobility, Ola, Uber, share ride, even two-wheeler share ride are also very common nowadays in at least big cities. May not be to the rural or the semi-urban areas. Then another thought that is coming is particularly in the big cities like Bangalore, Pune, and Mumbai, where people are spending about 2 hours on the road for going to their office or factories. How people can use that travel time constructively. So nowadays companies are providing the buses which are, having better sitting arrangement, and people can use their laptops and mobiles for doing their job. Also, people have now started willing to pay the charges for the shared ride, not only the petrol charges, but some little more about that. So people don't want to get worried about the parking and maintenance, cost sharing while you enjoy the driving, particularly from Pune when people are going to places like Nagpur and Nashik, etc., where the normal tickets of the buses, sleeper coaches, which are typically in the range of 1200, and at the time of Diwali vacations, they soar as high as 6,000 rupees. Even the aircraft tickets, which are about 3,000 rupees, they go to about 15,000, 16,000. So at that time, people share the cost of the transportation. People share their vehicle, and at the same time, they enjoy. Instead of one person driving the car, they enjoy the driving, and cost sharing also happen. Also, one of the things that has happened is even in and around Bhopal, you can see a lot of road infrastructure has improved across the India, not only in Bhopal. That increase the speed of the vehicle, and which calls for the enhanced safety needs. And of course, with all these shared vehicles like Ola, Ubers, etc., the safety which is from on-drive crimes is another challenge that is being faced. And post COVID-19 pandemic, hygiene is a becoming challenge, and that is the challenge which automotive industry is facing. Just to put a small statistics about Indian roads. Again, this is the government data. If I show this picture, I have mentioned the names of various places, but if you change even the name and put any other name of the city in India, the picture will not be different. So the automotive companies have come out with the solution for this. So global NCAP, the Indian vehicles are meeting safety norms. The accidents are artificially made at 64 kilometers per hour. These are intentionally controlled accidents done inside Tata Motors, and you can see the reaction of vehicle, reaction of the passenger sitting inside. There are specific cameras which has got the capacity of 1200 frames per second. Whatever you are seeing is in what typical common language, what we call as is a slow motion. But in reality, this happens in the fraction of seconds. You can just see what is happening to the occupant and how they are protected, what happens to your vehicle, what happens to your even child occupant, etc. These are real, kind of the accidents which can happen on the road. So again, in the interest of time, I will skip this full video. Again, taking this production data, what it means is the consumption of crude oil import of crude oil barrel per day. If you look at the number, which is about 1996, it was close to 520, 530 kind of barrels per day. Whereas in case of 2016, if you look at, it has gone close to 4,500, 4,400 kind of thing. And this is the data which was officially announced by Government of India in the Rajya Sabha. So this is the number of, exchequer which is going in terms of the foreign exchange from our country. So our minister, Government of India has come out with a clear-cut policy. Our minister has declared that they want to go with the alternate fuel, whether automotive companies want to align with them or not, they would like to go ahead. And as some time back, my another colleague Dr. I think what's his name from Dr. Manjini, he has shared the same data which I'm trying to again produce. If you look at the picture over here, on the top side you can see different nations and years. In European country, the Euro 1 norm is equivalent to BS1 norm, and in India, if you look at these yellow bars, they were representing the major cities, and blue bar represent the other areas. And there was a kind of phase difference of about 4 to 5 years in terms of the emission norms with respect to Europe. And now, even within country, from the major cities to the complete country, there was again a time difference of about 3 to 5 years. And now, from BS6 onwards, the whole country has migrated to one norm. And as my friend said, it has happened a year before. And why it could happen is, though the previous program got delayed, this time, for the first time, the fuel that is required for BS6 fuel was available well in time, rather ahead of time, and the development was possible. Also, there is a changing mode of the cargo. Like this kind of vehicles you have seen, they were moving all across the country. Then came the 407, which was popular for going inside the country, inside the cities. But with the further congestion, the model has changed, and between the intercity, people are going for the big trucks with the containers and trailers, and within inside the city, within the limits of municipal corporation or whatever corporation you have, those small vehicles are taking you to the last mile connectivity. Same thing is happening in the passenger transportation, intercity transport, intracity transport. These pictures are from Maharashtra, and now those are being replaced by very luxury buses. Even this is the DTC bus which you can see for the intracity. Now there are these kind of buses are being plied on the roads of Delhi. Even in Bhopal, these kind of buses are nowadays, you can see, and this is the different cargo modes those are available. Even electric vehicles are plying on MMRDA, that is Mumbai Metropolitan Region. You can see these electric vehicles, those are plying. Even between Kanpur and Lucknow, these buses are plying as a intra-city buses also. Again, taking you to this picture, what it means is the different, again, well to well efficiency. Again, this has been talked, so I will, in the interest of time, I will skip this slide. This slide, I would like to talk a little more. Why this low efficiency is being talked about? If you talk of the engine, it talks about the different numbers. If you talk about the standby mode, in the urban driving cycle, it talks about 17.2%, whereas in the bracketed figures are highway figures. So these are the energy consumptions in different system and subsystems of the vehicle. There are some aero losses, there are some rolling losses, kinetic losses, braking losses, driveline losses. So different losses are there which are trying to map, and accordingly people from the automotive industry have started working on it. The ones which are shown on the green are kind of really achieved the breakthrough, that is engine stop and go, where we could do the drastical improvement, whereas in other areas there is some little improvement. Whereas in case of the braking, because of the regenerative braking, there is a energy storage element that has come into the picture, and there is actually a creation of energy because of the regenerative brakings, etc. So again, coming to the need of electric vehicle, very clearly environmental considerations, climate change, fast dwindling petroleum resources, high current account deficit owing to the huge oil import bill. I showed that graph. Then worldwide shift to the more efficient drive technologies and fuel efficient system. But in spite of that, still the IC engines are considered as the inefficient engines, and accordingly battery electric vehicle and hybrid electric vehicles, those have emerged with motivation and drivers, migration journey, types and classification, and change content. This is what we are going to talk about. These are typical classification of hybrid and electric vehicles. If I talk about the first is IC engine vehicle, the emission is CO2. Then we talk about parallel hybrid electric vehicle, where there is a CO2 emission, but at the same time it's in the reduced quantity. Then range extended EV, Again, partially there is a CO2, but the range is extended. Then bimodal, that is independent IC and electric vehicle, those both drives are provided there. Then fuel cell electric vehicle. And if I talk about zero emission vehicle, it's totally, you can see there is no CO2 which is emerging out of it. When we talk about different characteristics, if I compare between the IC engine and electric vehicle, the number of moving parts in IC engines are very high, whereas in case of electric vehicle, they are very low. Reliability of IC engines is moderate, whereas in case of electric vehicle, it is very high. Efficiency, low, less than 45%, I told. And whatever this 45 number I am showing is with all the improvements, those have globally happened. Whereas in case of electrical vehicle, it is more than 90%, even at the crude stage. And there is some opportunity available for improving this further. Then it is bidirectional. In case of IC engine, it's not possible. Whereas in case of electric vehicle, they are bidirectional. Then power density, again, I have compared two global models, Chevrolet versus Toyota Prius, which is with the brushless DC motor. And the torque output standstill is no, whereas in case of electric vehicle, it's possible. Noise vibration, another area. In case of IC engine, it is with all the different materials, like whatever, even the materials which are developed by AMPRI, we could reduce the noise, but still it is moderate. Whereas in case of electric vehicle, it is so low that there is a complaint that people don't realize that there is a vehicle which is standing behind them. So can we add some noise into it? In fact, it's happening reverse way. So that is the challenge another here. Then exhaust gas pollution, again, as I said, in case of IC engine, it is CO, SC, NOx, particulate matter, that's high. And in case of electric vehicle, the vehicular pollution level is very, very low. When we talk about the power consumption at short test, you can see the speed at which the acceleration is happening. And in case of the power consumption, in case of IC engine, the power that is required is almost double the electric vehicle. That is about 50 kilowatt power is required from 40 kilometers per hour to migrating to 110 kilometers, whereas same change is possible with 25 kilowatt in case of electric vehicle. These are some of the efficiency graphs of electric vehicle. You can see with higher electric motors, the area which is having maximum efficiency is increasing, and it is close to 94%. So again, this is from the Borg-Warner, which is international. In case of electric vehicle, we think it is only the buses and trucks, buses and cars, those are coming. But Tesla is now coming up with this kind of cargo trucks, very, very high cargo trucks. You can see those testing that is happening in US, etc. And with this, there may be a question in your mind, when really the first EV was made. You may like to guess, but again, I will, in the interest of time, will move ahead. In 1800 years, the electric engine was introduced first time, and it was very quiet, slow speed, not scaring to horses and people. That is the requirement at that point of time. And this was in London in 1883. Then these are some of the later the designed cars, which are some of the again car prototype made by Henry Ford and Thomas Edison, two legendaries. Coming to the vehicle architecture, there are two parallel, kind of things are there. That is parallel and hybrid or series, we can say. You can see very clearly there are two streams extremely coming differently. So that is in series hybrid and parallel hybrid. That is the difference that is coming out. If you consider the thing which is shown in the kind of orange color, that is the electric vehicle power flow, whereas the one which is shown in the slightly darker color, that is the IC engine vehicle typically. The other part which is slightly brighter, these are the kind of batteries and electric storage vehicles, electric storage parts, etc. Then on the bonnet side, instead of engine, there is something what we call power system unit, which is ECU, engine control unit, which will control the engines. So then coming to the electric bus configuration, if I talk about, we'll go in a little more detail. There are various on the chassis. There are certain systems like auxiliary drive, junction box, then auxiliary inverter with DC-DC converter, etc. Then there will be traction motor, traction inverter. Those are the things which I have shown here. When we talk about the roof, there will be battery cooling or chiller unit. The battery packs will be on the top, and of course AC unit is also going to the top of the vehicle. So this is how your bus will look like when the electric bus I'm talking about. The global scenario on the electric vehicle and the outlook is the global electric car surpassed 5 million vehicles in 2018. You can see the number. Various countries such as Norway, Netherlands, Germany, France, UK have set the targets of migrating to total electric transportation between 2030 to 2040. Our country, India, also has the focused on electrification of transportation. Various vehicle manufacturers such as Volvo, Daimler, Volkswagen have announced plans to go only for electric powertrain for future models. That means they have stopped the development of new engines in the world. Then as per the forecast by International Energy Agency, the electric stock will be around 70 millions by 2025. World Bank already stopped the financing of upstream oil and gas projects after 2019, and they have raised funds to the finance shift towards clean energy. So the oil exploration, oil refineries, they will not be funded by the World Bank anymore. It's already stopped in 2019. Global electric bus stock, the authentic figure is available in 2008 from up to 2018. About 4,60,000 vehicles, buses I am talking, they are available globally. Of course, China accounts for 99% of the global market of electric buses. Shenzhen city operates the largest fleet of 16,000 electric buses in the world. Other countries include Europe, Latin America, USA, and India. Schiphol Airport, which is at Amsterdam, it operates 100 electric buses. In India, close to 1,031 buses operate in 11 cities, which is funded under the FAME scheme of Government of India. Department of Heavy Industries has proposed 5,595 electric buses to 64 cities, state government entities, as well as state transport unit for intra-city as well as intercity bus operation under FAME2 scheme. And it's not only the number which are on paper, but these are the actual reality that's happening. If we talk about the kind of distribution of vehicle which is going to happen, and if you focus around 2050, most of the vehicles you can see will be the fuel cell electric vehicle. There will be some battery electric vehicle. There will be some parallel electric vehicle, and gasoline engines. Practically, it will be kind of dead. That is what is the expected. And why this is happening is very clearly, if you look at the efficiency, even with the best possible efficiency, the efficiency is going to be very, very low in case of IC engines. You can see this color, whereas in case of electric vehicle, the efficiency is going to be very, very high. Then electric vehicle content, if we talk about, I have tried to compare the vehicular gasoline vehicle system, what is their function and what it's getting to be replaced in electric vehicle. So gasoline tank, which stores the energy to run the vehicle, it will be replaced by battery. The pump, fuel pump, what we call, or gasoline pump, what we call, will be replaced, which uses energy to run the vehicle. It will be replaced by the charger. Then gasoline engine will be replaced by electric motor. Then carburetor will not be there. Instead of that, there will be controller. There will not be alternator, but there will be DC-DC converters, and there will be DC to AC converter, which is not equivalent system available in the gasoline vehicle. And smoke control is required in case of the vehicles, IC engine vehicle, because there is a toxicity in the exhaust gases. In case of electric vehicle, the toxicity will not be there. If I talk about the number of parts, whatever I shown today, before this slide was a kind of qualitative. Here I'm trying to get the quantified data, and the total number of parts is going to be 5,560 diesel vehicle, conventional diesel vehicle, whereas total number of parts will be, it's not kg, it is actual numbers. Whereas in case of electric vehicle, it will be 4,830. Curb weight is 1,305 grams, kilograms. Whereas in case of electric vehicle, you can see there is a penalty, and the weight is going high up to 1,400 kg. And one of the reason is the battery pack weight instead of the engine and the fuel system. which is about 200 kg in the conventional diesel vehicle, particularly cars and SUVs I'm talking. The new generation electric vehicle, the battery pack weight itself will be 350 kg. So there will be a penalty of about 150 kg on this. The reduction in part counts is 730. Net weight increase is 95 kg. There's some offset that's happening, and power unit weight increases 150 kg. These are some of the phase-wise manufacturing program which Government of India has proposed. Again, in the interest of time, I will skip. This I am trying to show that different systems, how government has planned phase-wise manufacturing program to make sure that for in case of electric two-wheeler, electric three-wheelers, electric four-wheelers, how electric buses, how these parts and systems will be developed and localized in India under the Atmanirbhar Bharat scheme. These are some of the dates which I have shown, and most of the dates, except which are in the COVID era. In COVID era, some of the dates have been fired, but otherwise other dates are being honored as on today. Again, the same thing. There are about 21 systems which are being localized. Then India's new EV program is government focused on the electrification of transport, as I said earlier. Early EV penetration in transportation segment, e-rickshaw, e-auto, e-taxis and buses. In Bhopal itself, we can see there are a lot of e-rickshaws. I guess it is in a lot of cities in Madhya Pradesh also have these kind of vehicles available. Then EESL tenders for 10,000 electric sedan cars and 2,000 Bharat EV chargers are being floated in the market. The people are making, the infrastructure is getting available. Department of Heavy Industry has introduced the expression of interest for STUs, state transport units, for electric bus operation and public charging stations. Another thing that is being talked about is the swappable battery, that is a separate vehicle and energy business that is being talked about. And how the private vehicles to leverage this ecosystem. That is what is the focus of government. Also, there are some innovative business models. Those are coming up. Swappable batteries versus fixed batteries. So, like recently, government has passed resolution that even the electric vehicles can be booked without the batteries into it. Batteries can be bought separately. A similar example I will give you. In our home, we get the LPG cylinder. Few of the cylinders are very brand new, whereas few are look like. I don't want to have that kind of thing, but we don't mind because we are paying for the gas or LPG which is inside it, and not the shell or the cylinder that is being supplied. So the same philosophy is being thought of, because in electric vehicle, the 30% of the cost is a battery cost, or even little more than that. So people may feel that such a costly batteries, how can I give to someone whom I don't know? So that's why government has come with the scheme that you can buy the electric vehicle without even batteries, buy the battery from the open market, and then it can be swappable battery. When you are taking the nashta or breakfast in some of the break, by the time your batteries will be swapped, it will be changed with the charged batteries, and you are ready to travel further. Then city electric first buses on the OPEX model. So it's not only the government is buying the motors or the buses, but those are being operated by those people only. So that, like Tata Motors is responsible for MMRDA and New Delhi. So the operation and maintenance is given to the Tata Motor. They have floated some different companies. So likewise, the models is being worked out. Then also multimodal electric transportation solution, particularly in big cities like Mumbai, Delhi, and Bangalore. Whereas with single ticket, you can use auto rickshaw, taxi, bus, metro, all those, without buying multiple tickets. So multimodal transport, like from one place to another, which is kind of an end-to-end city, you can travel by metro. When you want to go inside your locality, there can be one electric bus, or to the last mile connectivity, or to the last home connectivity, you can have auto or taxis. Then electric shared fleet, Ola and Uber in Nagpur. The Ola has introduced about more than 200 electric cars in their fleet. Then electric fleet for delivery and e-commerce services. This Flipkart and Amazon, they are working on this. They are funding their partners to buy these electric vehicles and operate with them as a delivery partners. Then electric retrofitment solution, which is for the reuse of the vehicles, because we have a lot of vehicles which are already in our country, so we just cannot throw them off. So people are talking about electric retrofitment. Bharat Forge is working big way on this particular kind of technology. Of course, when there's a new changing technology is there, it has to have the regulation, because we are talking about electric vehicle and it will have a lot of energy stored into it. If I talk about the kind of energy, it is almost as good as 1 ton bomb on which you are sitting. But let me tell you, it is very, very safe. There are a lot of safety regulations, what we call as CMVR homologation. Tata Motors or any automotive manufacturer in India, or rather in the world, cannot bring their product without getting certified from the agencies like AIR, ARAI, etc. So there are a lot of stringent safety norms. Those are being provided. Standardization is being done. These are the different electric vehicle regulations. Those are being used. I have given the comparison of Indian standard as well as the international standards. Again, the charging regulations are coming. There can be AC conductive charging, or there can be DC conductive charging. Both type of chargers will be available. Again, it has got some plus points and minus points both. Then again, this is a very common picture. When our first introduction with lithium ion battery we started, we had different kind of chargers. I mean, I myself has iPod some time back. Then I had Samsung. Then I had mini USB and Sony Ericsson. So instead of having 3 or 4 different kind of connectors, I used to buy this 10-in-1 USB charging cable, which was available. But remember, this we are talking about milliamperes, and in case of the electric vehicle, we are talking about kilowatt hours. So a huge change in the energy. So this kind of small cables will not work out. So there is a standardization that is happening, and these are various reference chargers. Those are being used particularly for charging couplers protocol. And in India, the last one, which is called as CHAdeMO, this is the particularly adopted for DC high power fast charging, that is being standardized all across India. Then the development challenges, there are a lot of opportunities available in terms of the high efficiency batteries, then electronic control units, then motor generator, then DC to DC converter, DC to AC converter. These kind of opportunities are available. I will just show EV powertrain development cycle. The first, it starts with the domain and domain expertise, then simulation and modeling tools chain. That is the first step. Then we migrate to the actually tool chain, then model process, and then the actual configuration of the design, then harnessing design and packaging, and then finally productionizing. So these are the various steps into it. Electric vehicle chassis, in case of the electric vehicle lightweight chassis design is happening, and where I think AMPRI can definitely contribute big way. ARAI working on this structural adequacy evaluation on this particularly. Then electric safety EMC, I think sometime back our friend Mr. Bhargava has indicated about EMC readiness, which AMPRI has. So those can be leveraged. Then these are the various EV components which are being developed and are getting developed very soon. Electric vehicle, these are the business opportunities. Those will be available. Electric chargers, particularly if you go to the automotive companies who are producing the electric vehicle, in their dealerships, you will find this kind of structure already available. And very soon, these kind of structures you will see even on the petrol pumps. Again, the most important thing here is what is required is the training of users and drivers. I am going to show a small video. Again, this is a video of a lady, but don't laugh. It has nothing to do with the gender, but this is the reality. When you don't know, when you're migrating from the electric vehicle to from diesel vehicle or gasoline vehicle to electric vehicle, when you get the indication that your fuel is towards the end, And when you go to the petrol pump or fuel pump, what will happen? You can just see the reaction of this lady. In US particularly, you have to operate the pump yourself because the cost of the human is very high there. So you have to operate yourself. So try, see how that lady is trying. Now she opened the lead, somehow she could find. Then she swiped her credit card so that the adequate fuel can be dispensed. And now she's in a fix where to fill in the fuel. Probably this is the Chademo charger which I have shown you. Of course, it cannot accommodate the fuel pump nozzle. So anyway, so this is what I'm trying to tell you. So again, I will not, in the interest of time, will go for the full. But these are the kind of users for drivers as well as users. The training is very, very essential. Even for the fire personnel, this is the training is required how to handle the fire of these vehicles if it happens. Also for the insurance claim, you will have to, people needs to be trained. Then for the legal machinery, how those legal activities will be taken. Forensic experts in case of some accidents, and particularly if some certain scams or deliberate crimes happen, then those forensic expert needs to be trained. And then electricians and roadside repairs, because even whatever the reliability is there, there is a need for roadside repair that may come up. Then this is the charging infrastructure. Two type of charging I have shown here. AC charging, or what we call as the onboard charging, and standalone DC charging. DC charging will be fast. Then these are the different charging methods. For buses, there can be what we call as the arm, which can go up, pantograph, what we call, and otherwise there can be swappable batteries. Again, with totally due respect to the colleagues from Tesla, whatever the efforts they have put, the purpose is to show what is the issue in the electric car, not to defame or blame any company. You can see what is happening here. I said that
Electric car company
fire
Tesla
people
has
needs
been
to
on
be
a
trained.
tear.
So this is how what
Its stock has soared this year, with investors juiced by the prospect of growth in electric car sales. But even on the brakes after this video emerged of its Model S burning in flames. What happened? The first thing you need to know is the battery pack of the Model S is located in the floorboards. The accident took place as the driver was heading south on State Highway 167 in Washington State. He apparently hit some metal debris in the road. The motorist decided to pull off the highway and the vehicle became disabled. He began to smell, and shortly after, the front part of the vehicle caught fire. Firefighters arrived a couple of days, but the fire reignited, requiring several attempts to extinguish. Tesla has reviewed the accident and says the flames were contained to the front part of this $1,000 car due to its design and construction.
So with this, coming to the challenges, is the biggest challenge is the cost of battery, low energy density of battery, safety, and need for lightweighting. I have compared the weights of different vehicles. The source is Wikipedia and Car Dekho. These are not the official data. So in case of Tata Nexon, which is IC engine, depending on the model and the systems you are choosing, it can vary from 1180 to 1315 kg in case of IC engine, whereas in case of EV, you will find there is a positive change, that is, there is a penalty of about 16%. In case of Tigor, it is almost 50%. Whereas in case of the bigger buses or the bigger vehicles, the penalty is less or very, very controlled, basically because the kind of engine and the kind of gearbox that is used for driving buses are very, very huge. In case of the passenger car, the agencies like AMPRI, they have already developed a lot of aluminum alloys and lot of systems into the aluminum, which we have seen some time back. And because of that, this weight penalty is coming very high. Then aluminum alloys for BIW and bus bodies, that is required. Multi-material joining technology will be required. Multiple materials can be required to be joined. Use of high-strength steel, ultra-high-strength steel that is required. Battery energy density from 100 watt-hour per gram to 100-150 gram watt-hour per gram we have already achieved. But again, this is very, very small compared to the requirement of the day. Also, there is a challenge in the battery chemistry. NMC, what is called as, or lithium, nickel, manganese, cobalt oxide batteries are very popular. But again, there is a challenge of temperature in this. Very suitable for European environment where the temperatures are low. But tropical countries like India, the battery management is becoming a problem, and that also adds to the cost and weight of the vehicle. Another battery chemistry which is suitable for the tropical countries and where the temperature controls are not much required is LFP, or lithium iron phosphate batteries. The efficient battery temperature management is also required. So these are some of the challenges. There are different kind of vehicle and different kind of challenges which I have tried to tabulate over here. If you look at this particular area, this particularly the yellow graph which is below needs, that indicates the work that is done into the battery management, but still a lot of activities and a lot of work is there. So with that, I come to the end. Of course, this presentation was prepared assuming that there will be face-to-face interaction, but only questions I may not be able to take. So thank you very much. I'm thankful to Tata Motors management for allowing me to make this presentation, as well as CSIR and AMPRI, particularly Dr. Avnish Kumar Srivastava, Dr. Rathore, and all other people over here who invited me to deliver this talk, and of course all of you for listening to me patiently. So thank you very much. With this, I stop my presentation.
Thank you. Thank you so much, Engineer Udayan Pathak ji, for this beautiful talk, for this so nicely you have highlighted and in detail, in depth, you have shared the importance of electrical vehicle and the challenges what we are facing and how we can implement practically in the near future. You have shared about the electrical vehicle, its importance, wherein the lesser number of parts are required, noise vibrations are less, no exhaust gas emissions are there. You have shared the high reliability, efficiency, power density with bidirectional and energy replication, etc. The importance of electrical vehicle. You have started your talk about the showing the mixing of the vehicle transportation which is available now. You have shared various videos about the India of highway, road accident, etc. The testing that has been practically done in the institutes, and parallelly you have shared about the crude oil import barrels day which is increasing day by day. You talked about the changing cargo mode, public transportation, intercity, intra-city availability. It has just started with the electrical vehicle. You talked about the battery electric vehicles and hybrid electrical vehicles. You have shared the typical classification of hybrid and electrical vehicle also. Beautifully, you have shared the differentiation between the electrical combustion engine as well as the electrical vehicle. You talked about the efficiency graph of electrical vehicle as well. You have shown the history of car, and as you discussed that electrical vehicle architecturing and the electrical bus is also been shared by you. Electrical vehicle global scenario and the network outlook has been highlighted by you beautifully, and you have shared the importance of this scenario, what is the present scenario and how in future we have to move ahead. The electrical vehicles change content in the form of a battery, charger, electrical motors, etc. You have shown and tried and cleared out our audience how we have to move with this electrical vehicle by comparing the typical passenger vehicle, that is a conventional diesel vehicle, and new green electrical vehicle as well. You talked about the India new EV program and told that how the government is now basically focusing on the electrification in the area of transportation in the form of e-rickshaw, e-autos, taxi buses, etc. Innovative business models like multi-modals, electric transportation, solar in city, electric, etc. has also been shared by you. Various regulations by Government of India wherein they are focusing in various things are also been highlighted. Electrical vehicle charging couplers, protocols, standardization talked about electrical vehicles. It was a really, really wonderful presentation wherein we could know about the importance of these electrical vehicles. And at the last, you have told about the opportunities and challenges that are being faced in this particular area. But we are sure in the near future, we'll be doing and using these electrical vehicles, and it will be running all over in the roads of India as well as internationally. Thank you so much once again, Engineer Uday Pathak ji, for your very nice, informative, knowledgeable talk in this very, very special occasion, very special day, National Science Day that we are celebrating here. Now to move ahead, ladies and gentlemen, I would like to invite our next speaker to address the August gathering, Shri P.S. Sardar, who is the Deputy Commissioner of Navodaya Vidyalaya Samiti. So I request Shri P.S. Sardar to please give the address to the gathering.
Namaskar, everybody. Dr. Avinash Srivastavji, Dr. Mandal, Dr. Bargo ji, Dr. Sadananda Misra ji, Sarika Verma madam. Actually, I have delighted to speak about the inspiration only, because on this day, all of us know that Sir C.V. Raman had announced the discovery of the Raman effect, for which was awarded with the Nobel Prize in 1930. Today, actually, I wonder and happy also to know the students of Jawahar Navodaya Vidyalaya from 6th class to 12th class have joined this webinar. And teachers also have joined. Even one student of 6th class, he is passing some comments also. Very good comments. I appreciate him. Today is the opportunity which our students have got to hear the eminent laureate scientists who have presented their presentation here. And definitely they will motivate from this speech. All of you know that the Raman effect has been used in many areas, including biology, chemistry, medicine. The Raman scanner, a device used to detect if someone is carrying illegal substances, uses the sample principle, same principles. So what I thought, from where he got this inspiration. The story goes back to the days after his degree honor in physics at 16 and MA degree at 19. He was selected as delegate of Calcutta University for the International Universities Congress in London. And on his return journey by ship, the vibrant blue water of Mediterranean Sea confused him and made him think deeply. He wondered, a glass of water does not have any color of its own, but the same water in the deep sea appears a brilliant blue. And he dived deep into research, trying to understand how light behaved when it passed through different substances. And on February 28, 1928, as our sir said, an experiment showed a definite faint greenish glow in glycerin. This meant that the molecule in the liquid were changing the color of some of the light passing through it. This resulted in the discovery of the phenomena that was named the Raman effect, and it created a stir in scientific circle around the world. Of course, we know this year's theme is highlights the future impact of science, technology, and innovation in the field of education and work. Challenges from 2020 has been for all of us This stormy year has given birth to the promising product. The scientific community, when faced with the shared problem, can rise the challenges and came together to refocus, research, and innovate. India, being most populous country, has many challenges handling the COVID situation, but the innovation of the vaccine by Covishield in short time shows India has caliber. As Indian, I see extremes of science and superstition. Because of COVID-19, we are bound to get closer to technology innovation like video conferencing, internet, mainly in education. Impact of science, technology, and innovation is high. Our educators have taken efforts to adapt to the new ways to educate students. Virtual classroom were gradually developing past 3 years, but COVID-19 has given a push. As you know that from last year, from the month of March, everywhere we are attending classes through this one on virtual classes. Even experiment also we are doing virtual. In our Jawahar Navodaya Vidyalaya, around 50,000 students are learning through online mode. Future of science is artificial intelligence, robotic. This science day, I want to say we innovate, believe after asking why, how, and what. I would like to bring to your notice also that as the government of India launched the Vigyan Jyoti program in our Jawahar Navodaya Vidyalaya situated in Madhya Pradesh, Odisha, and Chhattisgarh, around more than 500 students, particularly girl students under Jyoti project, Vigyan Jyoti project. They are doing their scientific work, and we are trying to develop their scientific temperament and interest. Of course, our Vidyalaya, our students have attending many webinars, quiz, moral preparation, virtual lab visit, 6th India International Science Festival 2020, which was held. Fun with maths, making models, science movies, play with chemistry, home test, biology model, scientist chart. This participation in IISF 20, woman scientist attending the program, entrepreneur, conclave, student science village program, fun with science, the curtain raiser of International Science Festival, National Cyber Security Awareness Week, visit of different institutions like Physics BBSR and IMMT, National Science Teachers Congress also we are conducting, and we are providing platform to our students and developing their interest and scientific temperament so that they are the future scientists. Today they have attended this webinar, and of course I think they are today inspired a lot, and they will develop their research-based attitude after going through this presentation. Actually, 2 minutes I am given by the Dr. Satananji Misraji. As you know, because of this research work, Dr. Satananji also working on laser, different type of lasers. Definitely, it will be work in future. And now also, our some eminent scientists have presented some laser-based experiments also. So once again, I would like to thanks to CSIR and AMPRI for giving me this opportunity, and express my gratitude towards Sir C.V. Raman. Thank you very much, sir.
Thank you, Sri Sada. You talked about the starting with the discovery of the Raman effect by Sir C.V. Raman. Then you talked about the COVID-19 vaccine. Therein you showed the importance and you highlighted the virtual classroom teaching also. how, why, but, etc. are the very important point wherein the student should talk, discuss, and think so that they can have a good, better futures in the term of scientific and technological innovations. You talked about the Government of India Vigyan Jyoti program and shared the various platforms that Navodaya Vidyalaya is giving to their students so as to develop their overall personality. Thank you so much, Shiv Sardar. Now, ladies and gentlemen, to move ahead, our next speaker to address the August gathering is Shri S. Srivastava, who is Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal. Now, I would invite Shri Srivastava for his address, please. Shri Srivastava. Sir, please. Thank you.
Good afternoon, all. I begin by thanking the Director AMPRI, Sri Avinash Srivastava for this webinar. I also thank the scientists and the other presenters of this webinar. As you all know, the Jigyasa was the initiative under the inspiration of Honorable Prime Minister. And since 2017, the students and teachers of Kendriya Vidyalayas across India, they have been participating in various activities of CSIR labs. And through this program, these prestigious research laboratories of CSIR, their portals were opened for the students and teachers. And the students who probably never dreamt of ever visiting these labs, their dreams became reality. They started visiting these laboratories and began interacting with the scientists over there. As you all know, the CSIR labs, through 11 modes of interaction, they engage with the students of Kendriya Vidyalayas and also with the students of Navodaya Vidyalaya Samiti. And through these 11 modes of engagement, they instill the scientific temper and they encourage and expand the inquisitiveness of students. Inquisitiveness, which is key to developing the frontiers of science, is innate. It is not, it does not come from outside. It is innate, inherent. And child, we believe that child is a natural learner and child is inquisitive by nature. The only thing is that in the system of education, the mechanicalness of education system sometimes it actually suppresses the inquisitiveness of the students. The rut of examination, the rut of teaching actually becomes so heavy that the inquisitiveness and the innateness of child's curiosity gets marred. So we elders, those who are related to education and those who are working with education system, it is their prime responsibility to see to it that the children's inquisitiveness and their desire to know, the Jigyasa, as the whole initiative is very aptly worded. Jigyasa means inquisitiveness. So this inquisitiveness should remain a permanent feature of a student's life. He should remain a Jigyasu till the end of his life. And through this initiative, we actually hope that we will make our students a permanent Jigyasu. All students and teachers will become permanent Jigyasu in their various efforts. They will try to know how things happen, why things happen the way they happen. They will look their environment more seriously, more deeply, and they will see various features, and they will be with an inquisitive mind. They will try to solve their present problems and also future problems. We have seen, and I am thankful to for apprising all of us with the recent developments in various fields. I'm thankful to AMPRI for showcasing to us the various products and the various processes which are of cutting edge nature. And students and teachers have been immensely benefited. And the talk by Uday ji, in which he briefed us about the electric vehicle. And in fact, I have been very curious to know about electric vehicle and how soon electric vehicles would come into India. So I was very curious. And incidentally, his talk today has actually satisfied me to a great extent. One suggestion I would like to give to CSIR-AMPRI people, and I hope that they will do something about it. The presenters, in fact, since the time is very short and the interactive session normally does not take place, so if their contact details, their mails, etc., or if their mobile number, if it can be shared with us, in turn we can share with our students. So in case if the students have some follow-up questions, or if they want to pose some specific query on the subject which the presenter has discussed in his talk, they can follow up by a mail query or by telephoning to the presenters directly. So this would be, in fact, a great help to all students. And since many students are also connected, Kendriya Vidyalaya students are connected, and Navodaya Vidyalaya students are also connected. My message to thousands of students and teachers would be that today we are celebrating National Science Day. National Science Day, as you all know, is actually celebrated to commemorate the discovery of Raman effect by the most famous Indian physicist, Sir C.V. Raman. Raman effect, in fact, my colleague Sardarji, in fact, enlightened all of us about the discovery of Raman effect and its various applications in different fields. C.V. Raman, as we all know, he was a great physicist, and the whole India is proud of this son of India. And by observing Science Day and by observing and in fact honoring the contributions of Indian physicists and physicists elsewhere also, we actually plan to expand inquisitiveness in the minds of the students. Children should remain a lifelong Jigyasu. That's the message of this program and under this initiative called Jigyasa. I thank AMPRI Director, Sri Avnish Ji, for this webinar and for extending an invitation to me. And I look forward to many such webinars in the offing. And AMPRI goes on conducting such webinars in the interest of the students, popularizing the students, disseminating scientific ideas so that we all can become scientific in our attitude, in our working, in our dealings. We should become scientific. We should see facts as they are, far from being a dogmatic person, going by the superstitions, going by the popular culture called Bhed Chal in India. We should become scientific. Every decision that we take, there should be science behind our decision. Everything that we think, we must think logically, rationally, scientifically, and we must adopt scientific process in our dealings. And if we do that, then only that would be in fact a return of having been educated in science in our schooling and our college days. So this is the return. This is the Guru Dakshina that we seek from our students. And the Guru Dakshina is that you promise us that you will remain scientific, you will remain Jigyasu, you will remain inquisitive, and you will remain fact-based. You will not be dogmatic. You will not be carried away by the opinions of others. You will not be opinionated. You will be scientific. You will always gather facts, collect relevant factors, and analyze those factors scientifically, logically, apportion right priorities to those factors. And then in a logical and rational manner, you will take decisions. This will be the Guru Dakshina that we seek from our students and teachers, and hope my students will not deny us this Guru Dakshina. Thank you, AMPRI, for extending this invitation. Thanks to all of you.
Thank you. Thank you, Shri Srivastava, for such a nice talk. You started with the vision of PM about the Jigyasa program. You have rightly said various activities have been involved at CSIR labs related to the students so that they can interact and they can see the dissemination, popularization, and other things, whatever is happening in these institutes. You have also talked about the importance of Raman effect. You shared the Science Day, the Jigyasa program, and what are the changes that can be done in the student life through this Jigyasa and what we are expecting. And about the suggestion, it is the contact details and all that. I agree with you. And to the audience, I can say that you can have a website look on our website of AMPRI, as well as you can have a direct mail to the director@ampri.res.in. We are always available 24/7 and we are there to share all your doubts, queries, and anything students. We are there with you. So thank you so much once again, Shri Srivastava, for your addressing. Now, ladies and gentlemen, the occasion has came for the know-how transfer. The know-how technology that we have developed here in the Bhopal, CSIR-AMPRI Bhopal, is the AMPRI Care Disinfectant Box UV Rays Hybrid Technology. Basically, when we talk about this technology, what I can say is during the last almost a year has been there when we had suffering for the pandemic, we have used our expertise, whatever we have developed here in the AMPRI, and the expertise and the scientific and technological innovation. This has led to develop this technology wherein we have developed a box with a special type of a material, and along with that we have the inside of the things. So now, ladies and gentlemen, I like to invite our industry partner, Dr. Ketan Apte, who has taken this know-how, and he'll be sharing his thoughts with us. So, Dr. Ketan Apte, please.
Thank you. Thank you for giving me this opportunity. I would, first thank Dr. Avinash Anvesh Srivastavji, Dr. S.K. Rathorji, Dr. D.P. Mandal, Engineer Bhargava, Dr. S. Manjini, Engineer Udayan Pathakji, Sri S.P.S. Sardarji, Dr. Sri P.S. S. Srivastavji, and Dr. Sarika Verma and her team for giving me this opportunity. And all, of course, all the participants of this today's Science Day celebration organized by AMPRI Bhopal. I feel extremely honored to be a part of this function and to be able to speak a few words in the presence of such an esteemed group of people, great scientists and a premium institute of the country who have contributed to such a large extent to the well-being of the society. It would have been a great opportunity to meet and interact with everyone in person. However, due to the present situation, we had to make do with a Zoom meeting. Hope to make up this loss by a visit to AMPRI Bhopal as soon as the travel restrictions are lifted. Regarding my academic background, I have been in the field of biomedical engineering for the past 30 years and have been lucky enough to continue working in this field too. Radiology equipments has been my area of focus, and more so the X-ray based products. We are dealing in handheld dental products to the CT scan machines and installing and servicing them and looking after maintaining their life cycle throughout. We are also accredited body by the Atomic Energy Regulatory Board, which controls the use of X-ray machines in India. Most of we are in this accreditation, we do the testing of these machines with specific tools which are Unfortunately, at present, most of these tools are imported. We have started the process of developing these tools in India and to some extent have been able to do so. But we seek more efforts and also help from other institutes like AMPRI to go and further develop these products so that we can have the entire QA tool developed in India. As Madam was mentioning, COVID-19 has brought the entire world to a standstill in 2020. We have all still not come out of the shadows, and at present situation is still green. During the lockdown, we had a lot of free time and started discussing with Dr. Verma and her team what we could do to help the society in its fight against COVID-19 virus, being always connected to the hospital industry for the last 30 years. We found out that the C band of ultraviolet light is a very effective tool to kill viruses, bacteria, fungi, and many other pathogens. If we could develop a device using UVC, it could not only be effective for the present situation, but also in the future, could be used in the future. Very kind enough to share her team's efforts in this regard and they shared the AMPRI box which they have developed to kill the pathogens of all nature. The uniqueness of this box is that it not only uses the UVC bandwidth to kill the pathogens, but it has a special coating of a nanomaterial developed entirely by AMPRI, which enhances the effectiveness of the uh, pathogen killing activity of the UV lamps. So we are in the process of taking this technology from AMPRI and hope that we can extend the use of this technology in many more applications which we feel are important and required in the industry for the industry to go with into the market. I would like to thank Dr. A.K. Srivastava again, the director of AMPRI Bhopal, and the Dr. Rathore and Dr. Sarika Verma and her team to give App Medical the chance to work with their team of highly qualified scientists and develop this product. I would now take the opportunity to say thank you and hope that we can actually come up and fulfill our honorable Prime Minister's dream of Atmanirbhar Bharat in killing the pathogens and making this world a far safer place, as the Serum Institute of India has also been doing. Incidentally, both our organizations are in Pune, as well as Tata Motors. So thank you, sir. Thank you, everyone.
Thank you. Thank you, Dr. Apte. It was really a good opportunity for all of us to have the interaction, and definitely with the interaction with the society, we will give the good and the best in the form of this know-how to the society. Now, I would request Director CSIR-AMPRI Bhopal, Dr. Avnish Kumar Srivastava, to have a few words, please. Sir, please.
Thank you very much for giving me again the opportunity to talk. And since now time is running like short and everybody must be waiting for lunch, I had a option of briefing what our all distinguished speakers have spoken. But I think Sarika has already briefed in a very nice manner. Only thing what I feel that the talks which have happened, we should have something go ahead kind of what is next, how to come closer and in a collaborative mode, and the kind of the ability and expertise AMPRI is having in the field of metallurgical materials. Here we have talked only about the metallurgical materials and their possible applications, because we saw that Jindal Group and Tata Group is our chief guest. So we focused only about the metallurgical materials, and we think making this today's program as a platform, we should carry forward and have another meeting at some stage where we could be more focused and think about having some targeted projects, programs, where we can give some really useful output to the society, maybe in another next 2 to 3 years or 5 years time. So that kind of goal we should have. And this was a beginning opportunity, National Science Day. So thanks to our well-known, renowned international Sir C.V. Raman Nobel laureate, that we use the National Science Day as a platform to discuss further and utilize this opportunity in terms of some tangible output useful for the society in future. So Dr. Manjini is here, Engineer Udayan Pathak ji is here, and my own colleagues, they are listening. At the same time, this platform was used to inculcate new developments in the field of science and technology to our young students of Kendriya Vidyalayas and Navodaya schools. So thanks to CSIR Jigyasa program. Now coming to the technology know-how transfer which we are going to have, I must thank to Dr. Ketan ji, and I see one more name, Dr. Geeta ji. They both are here. So CSIR-AMPRI has developed a know-how called, it is a know-how called the hybrid equipment with its unique characterization wherein simultaneously and synergistically various components plays a very important role for the sanitization purpose and keeping the things free from germs, microbes, as Dr. Ketan also said, including bacteria, viruses, etc., and thereby saving the society to get contaminated from severe disease caused due to the harmful microbes. So it's a unique technology, even utilizing the some kind of nanomaterials in this. In this regard, the CSIR-AMPRI has also filed a patent already of this know-how technology. And my sincere thanks and best wishes to our new collaborator, industry partner, Dr. Ketan Apte and Dr. Geeta Apte, for taking this technology from CSIR-AMPRI, showing trust on AMPRI's scientists, their research, their technology. And technology transfer is one thing, but we are with you as far as technical support is there. As long as your product reaches to society, we are with you. Anytime you can come back, discuss, you can improve the technology, you can improve the product based on the suggestions and the requirement which comes from the society side.
Thank
So
you, sir.
you are basically the channel between the society and a national R&D lab. Okay, so thank you very much.
Thank you, sir.
So with this, thank you all for giving wonderful speeches, very useful talks we have heard. And thank you all the students, their faculties, their commissioners, principals, deputy commissioners, family members, my own CSIR-AMPRI staff members, and directly or indirectly, who are connected to this National Science Day virtual platform today. Thank you very much. And I hope that in future also we will keep meeting there. Thank you.
Thank you. Thank you so much, sir. Now I would invite Dr. Rathod for this know-how technology transfer fix and the exchange program. Dr. Rathod, please.
So it is possible to do many things on virtual platform. So this is a technology document, and this is the occasion where we are exchanging our technology document with Messrs. After Medical Systems. And from today onwards, we are collaborator and we are basically one. don't think any differentiation between AMPRI and after medical system. We are one, and we have now taken joint responsibility to take this technology to the society. Thank you very much. We are gathering here, so just wait a moment. So it's a wonderful moment. Technology takes years to come to this form because things start with always with fundamental research, then applied research, and then technology readiness level and all those stages you have to go. Then it should be accredited, very well tested by accredited labs, and then we start searching industry partner who can take these kind of technologies to the society. And this is what finally we could do today. And I tell you that in COVID time also, this is the fifth technology know-how we have transferred from AMPRI Bhopal. And in relation to COVID, we transferred a technology of the makeshift hospital in collaboration with CSIR Central Building Research Institute. And that COVID hospital is already built clinic in JP Hospital here in Bhopal, and it is being heavily used for the COVID patients. So that lab to land, that research has already gone. And then we transferred this mask and sanitizer to one startup company, and our mask is already on Amazon, and the owner of that company is a startup, and he is very happy with that. So several such things are going on as far as COVID related things, and in general also, because this kind of the boxes, sanitization boxes, they are used for various purposes. So this is kind of work we are doing, because as a scientist, it's not only to do only a very framed work, but also the work which is urgently even required for the society. So we are committed for that. Thank you very much. Whenever you visit Dr. Ketan and your team to AMPRI, we will show many such technologies which are in pipeline. Thank you very much. Namaskar.
Thank you, sir. Thank you for this know-how transfer, and thank you to Dr. Ketan Apte, Mrs. Apte, and his team. Definitely, we in the association with the industry, we will be giving this to the society very soon. And now to move ahead, ladies and gentlemen, we have a small video with you regarding to the work which is related to the COVID-19 prevention that we were doing. Now I request IT Division Scientist Dr. R.S. Ahirwar, Senior Principal Scientist, and Sri Narendra, Scientist, to kindly screen the video.
CSIR Advanced Materials and Process Research Institute, in short we call it CSIR-AMPRI at Bhopal, is one of the constituent labs of CSIR, that is Council of Scientific and Industrial Research. Under this lab of CSIR, that is at AMPRI Bhopal, we work on lightweight materials, smart and functional materials, nanostructured materials, waste to value added materials. And these materials in turn they get converted into different outputs like publications, patents, and products, that is technology know-how transfers. It's a national lab of international repute. As far as COVID-19, this pandemic of coronavirus is concerned, we worked on different directions. Being an engineering lab, we tried to do our best using our capacity, efficiency, and the expertise of our scientific, technical and non-technical manpower. We worked on knowledge generation, knowledge dissemination, industry interface, societal interaction and innovative products. In terms of knowledge generation, we published some very important papers in international journals, including even considering the nanomaterials of graphene, and we are probably the first in the world to publish in Science Reporter saying that graphene can work as a protection material against coronavirus. Other publications like on antimicrobial coating, biosensors, medicinal plants and so on. Then we did knowledge dissemination like organizing conferences, workshops, training the people and also making aware how to protect yourself, how to prevent yourself from the COVID-19. We had these programs under Jigyasa, teaching the school students, their parents, their teachers, their deputy commissioners, principals and under skill development program, certain programs we have run. Then we interacted with society in terms of teaching them or making aware how to protect themselves from coronavirus. In this case, we reached to more than 50 villages of Madhya Pradesh and Chhattisgarh. We distributed our masks, sanitizer, soap and posters making them aware about the coronavirus COVID-19. We also distributed our soaps, masks, then sanitizer and posters to government officials like police personnels, bank officials and common man. Then further we worked on different products, technologies we are trying to develop, and we started with face mask and sanitizer with extra skin care. And this technology we transferred to a startup company in Indore, and I am happy to tell you that face mask is already in the market. It is commercialized after lab testing and sanitizer work is going on. In addition, we are working on to develop different sanitizer boxes with UV and nanomaterials, hybrid boxes, without UV with nanomaterials, hybrid boxes. We are developing some other products like some biosensors and so on. Then we are working on different other products like different high quality masks like e-mask, tribological mask, herbal mask, graphene layer incorporated mask for different sectors of the people, not only to common man, but even for doctors and other healthcare people. So, in total on different fields we are working. We are developing antimicrobial coating to protect ourselves from this COVID-19 coronavirus, and this coating can be used for different metallic surfaces and therefore one can protect ourselves. So, in total in 5 directions of knowledge generation, as I said, knowledge dissemination, societal interaction, industry interface and innovative projects. In all these directions our scientists, technical staff, non-technical staff, students, project fellows, we are working in one team, and we are also getting associated with CSIR as a whole. CSIR as a whole also has 5 pillars where different directions they are working, and we are associated with hospital assistive devices among 5 pillars of CSIR. With this, thank you very much. Jai Hind. Dhanyavad.
Thank you. Thank you, Dr. Ahirwar, Dr. Narendra. Now, ladies and gentlemen, to move ahead, and almost we are in the end of our program, the Celebration National Science Day that we are doing. Now, I would like to invite my colleague, Dr. Satanand Mishra, for the vote of thanks, please. Dr. Mishra, please.
Thank you, Dr. Sarika. A very warm good afternoon to one and all present here. Myself, Dr. Stanley Mishra, Senior Scientist and Coordinator Jigyasa Program, CSIR-AMPRI Bhopal. Science is a way of life. Science is a perspective. Science is the process that takes us from confusion to understanding in a manner that's precise, predictive, and reliable. A transformation for those lucky enough to experience it. That is empowering and emotional. These are the words of Professor Brian Greene. Today, our nation is celebrating National Science Day. It makes the discovery of the Raman effect by Indian physicist Sir C.V. Raman on 28 February 1928. For his discovery, Sir C.V. Raman was awarded the Nobel Prize Physics in 1930. National Science Day is celebrated to spread message about the importance of science in life of the people. It is celebrated to discuss all the issues and implement new technologies for the development in the field of science. Its motto is also to encourage the people as well as popularize science and technology. I am very happy to share a great news on this auspicious occasion. The Indian Space Research Organization ISRO, in its first mission of 2021, has successfully launched the Brazilian satellite Amazonia first from Satish Dhawan Space Center, Sri Harikota in Andhra Pradesh, PSLV C-51 rocket, which is the 53rd mission of PSLV. Launched Amazonia first Brazilian primary satellite and 18 co-passenger payloads from the first launch pad of the Sriharikota Space Port in Andhra Pradesh. I heartily congratulate ISRO to achieving such a tremendous success. We are glad to have such an enormous participation on this occasion. We are concerned with school students, teachers, principals, and administrators from KV, Madhya Pradesh, and Chhattisgarh region, NVS Madhya Pradesh and Chhattisgarh and Odisha state and private schools of Bhopal and college students. We are also associated with researchers, technocrats, and industrialists, so it is a great hub of knowledge sharing. The large connectivity of participants in YouTube Live shows the grand success of the program. It is my privilege to propose a vote of thanks to this auspicious occasion. I would like to extend my warm gratitude to Engineer Udyan Pathak, DGM, Engineering Research Center, Tata Motors, and RC member of CSIR-AMPRI Bhopal and chief guest of this program for providing spotlight on electric vehicle evaluation and light weighting opportunities. Through his valuable words, we got knowledgeable keys about Indian automotive industry and transporting mode. The study of safety features through actual simulated and controlled bumping electric vehicle, global scenario, and practical outlook in India. All of us benefited by your kind words and knowledge. Thank you once again, sir. I would like to mention our deep sense of appreciation for Dr. S. Manjini, Associate Vice President, JSW Steel, Salem, and RC member of CSIR-AMPRI Bhopal for his remarkable words for presidential address, for showing the forward path towards the renewable energy sources, fuels to battery, greens environment, and major steps taken in steel manufacturing techniques, replacing iron with aluminium for green environment, and sharing carbon emission through different sources and remedies and solutions on it. I hope all participants are benefited by your excellent knowledge. Sir, thank you once again. I would like to acknowledge my gratitude to Dr. D.P. Mandal, Chief Scientist and Head Allied Composite and Cellular Material Division, CSIR-AMPRI Bhopal, for his wonderful speech on lightweight materials. You have given us idea about aluminum foam, different aluminum composites, carbon-based materials, multi-layer functional compositions. We are also glad to see different undergoing projects and applications like carbon foams, the interaction with different industries like automobile, Indian Rail, DRDO, Indian Navy, and dockyards, and so on. That was really superior. And the success story of department was really inspiring. Thank you, sir. Thank you very much for all inputs. I would also like to thank Engineer H.N. Bargo, sir, Senior Principal Scientist and Head Intelligent Material and Advanced Process, CSIR-AMPRI Bhopal, to put his effort for lecture on smart material actuators. You have enlightened us far to tip of the actuators and the smart materials like shape memory, alloy, and their use like 3D printing, automobile, electrical system, artificial intelligence, light, mirror and door controlling system. Thank you, sir, for sharing your valuable knowledge with us. I would like to express my special thanks to Sri P.S. Sardar, Deputy Commissioner, Navodaya Vidyalaya Samit Bhopal, to share the route for the innovation and success story of Raman effect and vaccine. Sir, your presence really strengthened us. Thank you, sir. I would like to express my warm gratitude Sri Somit Srivastava, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Bhopal region, for his kind words and about Jigyasa and Jigyasu. It's really matter. Thank you, sir. Chandana, I would like to express my warm gratitude to Chandana Mandal, Deputy Commissioner, KBS Raipur region, for joining with us. Thank you, madam. I would like also to express my warm gratitude to Tajuddin Sheikh, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Jabalpur region, for joining with us. Thank you, sir. I would also like to express my special thanks to Dr. Ketan Apte, Director, and Mrs. Geeta Apte Medical System, PVT Limited, Pune, for their support and joining with us and make the program successful. Sir, your confidence and faith towards our technology have given us immense pleasure, and it is a grand success for us on this auspicious day. Now, I would like to express my sincere thanks to our director, Dr. Avnish Kumar Srivastava, Director, CSIR-AMPRI Bhopal, for his precious and encouraging words and for throwing light on origin, working, and significance of different departments of AMPRI, and also about CSIR Jigyasa program. Sir, your continuous guidance and leadership is reason for AMPRI to climb the steps of success. Thank you, sir. Thank you again for leading us. I sincerely extend a hearty thanks to students, teachers, principals, assistant commissioners of Kendriya Vidyalaya Sangathan schools, Navodaya Vidyalaya Sangathan schools, state government and private schools, college students, and professors, principal from various colleges of Bhopal joined with us. I express my gratitude to Dr. S.K.S. Rathore, Principal Scientist and Head PPD, for his valuable guidance, and Dr. Gaurav Gupta, Principal Scientist, Engineer Naren Singh, Engineer R.S. Ahirwar, and team for organizing the program successfully. I sincerely extend a hearty thanks to Dr. Sarika Burma, Principal Scientist, CSIR-AMPRI Bhopal, for successful comparing the program. I heartily convey my gratitude to all the scientists, technical officers, admin officers, research fellows, and ACSIR research scholars, and all the staff of CSIR-AMPRI Bhopal. I express my sincere thanks to press, media, and TV channel reporters who are connected with us. Thank you once again. Jai Hind, Jai Bharat.
Thank you, Dr. Mishra. Thank you so much. So, ladies and gentlemen, we have came to the end of our program. Thank you to all of you for the participation and your contribution for the successful celebration of this National Science Day. Thank you so much. Thank you to all
Thank
of you
you very
once
much.
again.
Thank
Thank
you,
you.
all.
everybody.
Have a good day. See you again.
Thank you, sir.
Thank you very much for gathering, having patience to stay such a long for about 4 hours. Thank you very much.